So, good afternoon, good evening, and good morning to you all, depending on your geographical location. So, today we are now going to start the third day of the International Conference, Mathematical Sciences for the Advancement of Science and Technology. In short, we call it MAST. So, already we had 2 days. So, here we only share the Google Meet link to only the participants who are presenting. Mostly the participants and the audience are on YouTube. So you can see that on the first day, we had more than 650 views on our YouTube channel. So without any further delay, let me invite Dr. Saurabh Das from NIT Jamshedpur. So Saurabh, the session is yours. So he will be chairing this session. So Saurabh, please.
Thank you, sir, for this invitation and this opportunity. And good morning, good afternoon, good evening to everyone. Uh, Let us start our session. And first of all, welcome to this 16th MUST conference. And now we are starting our technical session 5A. And the first speaker is Dr. Sam Sundar from Rajasthan. And he will be talking about analysis of the family of integral equation involving incomplete I function. So, Dr. Sam Sundar, please
Good morning, sir.
start.
Good morning, evening. Screen is visible. Hello.
Yes, visible. Yeah.
Good morning to all of you. Today I present an analysis of the family of integral equation involving incomplete I function. These are outlines. Over the last 4 decades, mathematics and scientists have been at the fractional calculus and special function, wide range of application of significance in fields such as medical science, fluid dynamics, viscosity, signal processing, probability theory, control, etc. Fractional calculus is a unit of integer calculus, provides more accurate result and classical calculus. Therefore, it is widely used in the mathematical modeling almost of all science, engineering, medical science, education, etc. The scope of is extensive yet considerably expanded due to the development of new issues in engineering and applied science field. In addition, here development L function, H function, I function, their incomplete generalization of dimension. Mathematical modeling is the art of transferring real-world occurrence into magnetizable mathematical models whose theoretical and numerical analysis provide insight. In the methods of the obtaining solution of integral equation are typically beneficial in the science and engineering. That is why the chosen Fredholm integral equation consists the incomplete I function. The most of commonly used function in the mathematics, physics, engineering, and mathematical biology, and special case are incomplete I function. These are some privileges: incomplete I function, incomplete gamma function. The usual incomplete gamma function, lower gamma function and upper gamma function are represented by equation 1 and 2. Equation 1 represent lower gamma function and equation second is represent upper incomplete gamma function. The sum of both equations are find in complete gamma function. I function. In 1997, Rathi discovered the I function is defined by equation 3, where psi w is the infinite product series defined by a family of incomplete function defined by Jangid and Ictor in 2018, which leads to natural generation of a variety of functions. The equation 5 represent of a lower incomplete I function, and equation 6 represent upper incomplete I function. The sum of both function, and then find the if put the y is equal to 0 in equation 6, then find the uh, incomplete I function and convert to I function. These are some psi w and phi w, equation 7 and 8. Weyl fractional integral. The standard definition of Weyl fractional integral is given by equation 9. Mellin transfer, the standard definition of Mellin transfer is given by equation 10 with respect to phi, and the inverse Mellin transfer of phi 11. There theta is delta is a constant. Mellin transfer of incomplete I function defined by equation 12. As psi is the equation of is the transfer in Jangadan vector. Psi minus p upon dollar and y is defined by equation 7. This uh, solution of integral equation of fraternal equation type utilizing of incomplete I function. In this section, using the Mellin transfer method and regularized well fractional integral provide the solution of fraternal integral equation problem involving. Later, these are boundary conditions and circumstance UVR integer, positive integer such that this condition also satisfy a real kappa and dollar or real phi upon beta is greater than 0. Argument of C 1 upon 2 pi delta, delta is greater in relation. The integral transform of incomplete I function is defined by equation 13 with some multiply, some function multiply function of v. The main findings of this paper. And let us suppose that these are some conditions and boundary condition for UVR as positive integer, psi r beta as are positive real number, and these are holds. Then subsequent integration formula 0 to integrate 0 to infinity incomplete I function with z function defined by x upon u, then multiply some another function, then we find the integral 0 to infinity, and where these define the well fractional integral of phi u. Here phi u is defined by equation, sorry, equation 16. Psi u, that is this psi. Another term make the assumption of UVRST UVRS in positive integer, psi r positive real number, then the consequential integral 0 to infinity function of v and incomplete I function. This kernel is incomplete I function kernel is c x upon v to power dollar. Then the result is obtained only psi function has been solved by is use the psi function here, and the result is outcomes in the of x. That means here omega phi defined by there, and the phi of minus p upon dollar y is shown in the equation at this that is upper gamma incomplete I functions. That is upper incomplete. This sign is upper gamma and this sign is lower gamma. Remarks: this section presents the already available findings and the new findings of major the results. If the foot A and AIs and BIs is equal to 1 in the equation 14, then the result obtained by function and Ictol. Equation 14, this equation is present AI and BS all one, then result by in convert to incomplete H functions. Result obtained by Bansal and Manish Kumar Bansal and Ictol. The second remark, if we consider y is equal to 0 and aij is equal to 1 in the putting the equation 14, then result y outcomes in h function. If put the y is equal to 0, then and ai and bs, ar and bs is equal to 1 and y is equal to 0, then this transformation polynomial is convert as function. This result by obtained by H.M. Srivastava. Now we present some essential example based on main findings. If u is equal to 1, v is equal to r, and s replaced by s plus 1, then the kernel of I function, this c x upon v, is replaced by minus c x upon v. Beta 1 is equal to 1, phi is equal to 1, 0, and another phi psi I is 1 minus psi I is replaced, and phi I is 1 minus psi I is replaced. And also put AI and BI is equal to 1 in the theorem number 1, this theorem. Then result outcomes in Fox-Wright incomplete functions. If also put zeta r and beta as is equal to 1, then the frontal integral solution that uses the incomplete generalized hypergeometric functions. Also input the equation zeta and beta is 1, all zeta and beta, and also put if y is equal to 0, this equation, then the result convert to Fox-Wright function. These are solutions. The suppose they're taking the left hand first is the g, then they apply the integration order and substituents, some calculation, then the finding the main result. By figuring out the coefficient value of the various parameter of the incomplete I function, we also highlight some no outcomes. All conclusions are circular in many different fields with their aid and a wide range of using using fractional integral equation application, engineering and communication, probability theory, etc. The I function is the different in generalization, kernel of generalization and transcendental problems. These are some reference. Thank you.
Yeah. Thank you very much for this nice talk. So, audience, any question? If you have any question, you can ask. Okay, I think there is no question, but I have one query.
Yes,
Uh,
sir.
uh, you are discussing about incomplete I function, right?
Yes,
So,
sir.
how it is related to Fox-Wright function? Can you just show?
Yes. Firstly, you convert is this function is add function, and then replace by this is u is equal to 1, v is equal to r, s plus s replaced by s plus 1, and the kernel convert to minus, and beta 1 and psi s is 0, and psi and phi.
No. So my question is, will it be converted to Fox-Wright function or incomplete Fox-Wright function?
Okay, okay, sir. This equation 17 is y is replace y is equal to 0 in 17 equation. Then incomplete Fox-Wright function is converted to Fox-Wright function.
Okay. Okay. Thank you. Thanks a lot. Now we call our
Thank you,
next.
sir.
Okay. Now we call our next speaker, and our next speaker is uh, Dr. Emo Emir. Are you present? I think no. So we'll go to our next speaker, Dr. Manjit. I think Dr. Manjit, are you present?
Sir, I can leave.
Yeah, you can leave.
Okay, sir. Thanks.
Dr. Manjit, are you there? In the chat box, I saw. Paper number 33, Dr. Manjit. No, not there. Then I will call our next speaker, Kavindra Goswami, Dr. Kavindra Goswami. Dr. Krishna Nandan Burma. Anyone is there?
Yes, Krishnandan Verma.
Yeah. So
Can I present?
Hello. Yeah. Definitely. So
Oh.
let us welcome our next speaker, Dr. Krishnandan Burma from Assam. He will be speaking on the topic heat transfer on MSD nanofluid flow in porous medium over a horizontal permeable plate with Cu and Al2O2 nanoparticles. So, Dr. Burma, now the session over to you. You please present your work and try to finish within 12 minutes, which is the required time, including question hour section.
Okay, sir. Is my screen visible, sir?
Yes, it's visible. So you make it full screen.
Okay, sir.
Okay, fine.
Good afternoon, everyone. I am Krishnandan Verma, and I am going to give presentation on my work, heat transfer on MSD nanofluid flow in porous medium over a horizontal permeable plate with copper and aluminum oxide nanoparticles. So outline of my presentation consists of definitions, mathematical formulation of the problem, method of solution, results and discussion, conclusion, and references. So first of all, I would like to define nanofluid. So nanofluid is a special colloidal suspension of macro-sized particles referred to as nanoparticles in a base fluid. Nanoparticles used are basically made of metals, carbon nanotubes, carbides, etc., while base fluids used are oil, water, ethylene glycol, etc. Nanoparticles suspended in different base fluids have tendency to change the fluid flow as well as heat transfer properties of the base fluid. Many investigations on nanofluid are still going on to study its wide range of engineering and industrial applications. Due to enhanced thermal properties of nanofluids, they are used as coolants in equipments like heat exchangers, radiators, electronic cooling systems, etc. So let me come to the formulation of the problem. So the flow configuration is given in figure 1. So we have considered a horizontal permeable plate placed along the x-axis. Y-axis is taken normal to it. Now we have exerted a uniform magnetic field of strength B naught normal to the plate. The strength of the field is very weak, so we can neglect the induced magnetic field. The flow is considered to be steady and laminar and the fluid to be incompressible, Newtonian, and viscous. The nanoparticle, that is copper and aluminum oxide, have uniform spherical shape and equal sizes, and they will be used separately while water will be used as a base fluid. The base fluid as well as the solid nanoparticles are assumed to be in thermal equilibrium, and also there do not exist any slip between them in accordance with the work of Maleki et al. The effect of thermal radiation, viscous dissipation, and heat generation absorption is also considered in the problem. Now, due to the permeable nature of the plate, it undergoes uniform suction injection at the surface. The problem is formulated using a partial thermal and velocity slip at the surface of the plate that is in accordance with the work of Maleki et al. So the governing equations of the problem are given here. Equation 1 represents the equation of continuity. Equation 2 represents the equation of motion. So the important effect in equation of motion is the MSD effect, this term. This term is due to the porous medium term, that is the Darcy term, and this is due to the viscosity term. Equation 3 represents the equation of energy. So important effects in the equation of energy is effect of thermal radiation, this term. This term is due to the heat source effect, and this term is due to the viscous dissipation effects. So boundary conditions are given by equation 4 and 5. So along velocity component in x direction, we have assumed a thermal slip condition that is given by lambda 1 del u by del y. Here lambda 1 is velocity slip parameter. So along y direction, we have considered a suction that is given a minus VW, and temperature condition is given by TW, which is temperature of the plate, plus a thermal slip that is given by beta 1 del T by del Y at the plate. And away from the plate, the velocity in x direction is equal to U infinity, that is the free stream velocity. Temperature is equal to free stream temperature. The thermophysical properties of the nanoparticles as well as the base fluid is given here. So I would like to say that NF represents a nanofluid, S represents the nanoparticles, and F represents the base fluid. So here the dynamic viscosity of nanofluid is a ratio of dynamic viscosity of the base fluid divided by 1 minus phi. Here phi is the volume fraction of nanoparticles to the power 2.5. Here alpha NF is a thermal diffusion nanofluid. It is a ratio of thermal conductivity nanofluid by heat capacity of the nanofluid. Heat capacity expressed here. Similarly, electrical conductivity of nanofluid is expressed here, and the density is expressed here. Now, in order to calculate the thermal conductivity of the nanofluid, we have used Maxwell model that is given by equation 7. That is the ratio of thermal conductivity of the nanofluid by thermal conductivity of the base fluid is expressed here. Here, Ks represents the thermal conductivity of the nanoparticles, and F is the thermal conductivity of the base fluid. Here, phi will be the volume fraction of nanoparticles. And the heat flux due to radiation term is given by QR in equation 8. And now, to convert our equation to dimensionless form, we have introduced similarity transformation that is given by equation 9. Here, eta is the similarity variable, psi is a stream function, and theta is the dimensionless temperature. The stream function is expressed as u is equal to del psi by del y and v is equal to minus del psi by del x, and this will satisfy our equation of continuity. While the equation of motion and the energy equation in dimensionless form are given by equation 11 and 12. And the boundary conditions are also transformed, that is given by equation 13 and 14. And the parameters in our equations are given here, like Kp is permeability parameter, M is magnetic parameter, Fw is suction injection parameter, and so on. Here M0, M1 to M5 are all constants. Now, in order to obtain our similarity solution, we need to make our parameters independent from the space coordinate x. So what we'll do some transformation, like B0 is equal to A1 by x, K is equal to A2 by x, and so on. So using this transformation in our parameters, we see our parameters have now become independent of the space coordinate x. Like we can see all the parameters like magnetic parameter, permeability parameter, are all now free from x. And local screen friction coefficient and Nusselt number are respectively proportional to f double dash 0 and minus theta dash 0. That is given by equation 20. So let me come to the method of solution. So we have obtained our solution by using numerical scheme or using BBP4C MATLAB solver. Usually it is a finite difference code that implements 3-stage Lobato 3F collection formula, and it provides the solution which is fourth order accurately uniformly in dose interval AB. BPP4C takes three basic functions: initial guess of the solution, system of first order differential equation, and the boundary conditions. So in order to implement this solver, we need to convert our equation to first order differential equation. So what we'll do, we introduce some variables like y1 for f, y2 for f dash, y3 for f double dash, and y4 for theta, and so on. And our first order differential equations are given here, and the boundary conditions are expressed in this form. Now, with the help of the MATLAB code, we obtain our solution, and that will be represented in form of graphs and tables. So it is also noted that for carrying out the simulation, we have used a fixed value parameters that are given here, like Prandtl number is taken to be 6.2, Eckert number 0.05. And the solution is analyzed individually for copper water nanofluid and aluminum oxide water nanofluid, and it is in graphical form. These are the thermophysical properties of water, that is the base fluid, copper nanoparticle, aluminum oxide nanoparticle. Here Cp is the specific heat at constant pressure, rho is density, K is thermal conductivity, and sigma is electrical conductivity. The values, the experimentally calculated values of is given here, and we'll use this value to carry our simulation. So these are the results. So figure 2 represents the impact of magnetic parameter on the fluid velocity. So we can see with the increase in magnetic parameter, fluid velocity decreases for both copper water and aluminum oxide water nanofluid. This is basically due to the creation of Lorentz force due to a magnetic field which opposes the fluid motion. And in figure 3, we can see with the increase in magnetic parameter, the fluid temperature increases for both copper water nanofluid and aluminum oxide water nanofluid. So in figure 4, we can see the impact of permeability parameter and fluid temperature. So on both the nanofluids, we can see with the increase in permeability parameter, the temperature of the fluid enhances. And in figure 5 also we can see a similar results with here 5 represents the volume fraction of nanoparticles. So the increase in both the nanoparticles, that is copper and aluminum oxide, we can see the temperature of the fluid enhances. So then here lambda is the velocity slip parameter. So here we can see with the increase in velocity slip parameter, fluid temperature enhances for both copper water and aluminum oxide water nanofluid. Of course, the enhancement is more for copper water than the aluminum oxide water nanofluid. And in figure 7, we can see with the increase in thermal slip parameter, the temperature decreases for both the nanofluids. In figure 8, we can see with the increase in Eckert number, the temperature enhances for both the nanofluids. Here, Eckert number represents the effect of viscous dissipation effect. So we can say the effect of viscous dissipation increases the fluid temperature for both the nanofluids. In figure 9, we can see the impact of heat generation parameter on fluid temperature. So we can see with the increase in heat generation parameter, fluid temperature increases for both the nanofluids. So in figure 10, we can see the impact of radiation parameter on both the nanofluids. So we can see with the increase in radiation parameter, both the temperature decreases for both the nanofluids, and the decrease is almost same for both. So table 2, here we have computed values for skin friction coefficient to analyze the dimensionless shear stress on the surface, as well as the heat transfer rate, that is minus theta dash 0 for both copper nanoparticle and aluminum oxide nanoparticle for different values of permeability parameter, magnetic parameter, volume fraction of copper and aluminum oxide, and radiation parameter. So here we can see with the increase in permeability parameter, skin friction for both copper water nanofluid and aluminum oxide nanofluid decreases, and heat transfer rate also decreases for both the nanofluids. And with the increase in magnetic parameter, the same pattern we are seeing here, the skin friction coefficient decreases for both the nanofluids, as well as the heat transfer rate also decreases. And with the increase in copper nanoparticles, so we see the skin friction coefficient, it increases, then it again, it increases, but here we can see it decreases also. It increases, decreases, and again it show increment. For copper nanofluid, and for aluminum oxide, it decreases actually. And the heat transfer rate for copper nanofluid decreases, and for aluminum oxide nanofluid also it decreases. And with the increase in radiation parameter, the skin friction coefficient for both the nanofluids are unchanged, while the heat transfer rate increases for both the nanofluids. So this is the conclusion. Actually, we have already discussed in the graphs and tables, so I will skip it. And these are the references which I have used for preparation of this paper. Thank you. Hello, sir. Hello. Hello.
Hello.
Yes. Am I audible, sir?
Yeah.
Okay. Hello.
Yes, sir.
Hello.
Yes, sir.
Okay. Thank you very much for this nice talk. Any question from the audience? Is there any question you can ask? Okay. If there is no other question, let us thank the speaker again, and we call our next speaker.
Thank you, sir.
Our next speaker is okay. You can leave now. Our next speaker is Dr. Sinjan Chakraborty. Are you there? Or Pritish Ghosh, Dr. Pritish Ghosh.
Yes, sir. I'm audible.
Yes, yes, yes. So let us come our next speaker, Dr. Prithvish Ghosh, and he will be speaking on the topic classification and distributional properties of gamma ray bursts. So, Dr. Ghosh, now please present your work.
Okay, sir. Okay, sir. Thank you. So, good afternoon, everyone. My name is Prithvish Ghosh, and today my topic is on classification and distributional properties of gamma ray burst. The work is done by me and my co-author Shinjan Chakraborty from Calcutta University, and I am from Vishwabhat University, Department of Statistics. So, before going into our project, first we have to know what we have done here. So, in order to get a statistical overview of the gamma ray burst, we collected a set of data from the Bartse catalog, which we investigated, and with the help of correlation and the cluster analysis and some distributional properties. And we tried to classify this gamma ray burst in broadly two categories, which are the short gamma ray burst and the long gamma ray burst. So let's dive into our project. So this is the plan of our presentation, which I'm going through. So let's begin with the introduction. Before going into our project, we first have to know the term GRB, which is the gamma ray burst. So in gamma ray astronomy, the gamma ray bursts are immensely energetic explosions that have been observed in distant galaxies. They are the most energetic and luminous electromagnetic events since the Big Bang. So this type of this event, or you can say the gamma ray burst, is basically observed by their afterglows, which is usually emitted at long wavelengths like X-rays, ultraviolet rays, optical rays, etc. And in theory and also in a broader sense, gamma ray bursts can be classified into two parts, which are the short gamma ray bursts and long gamma ray bursts. So as I mentioned in the previous slide, the short and long gamma ray burst. So these two classes are likely to be created by different processes, but the end result is both. In the end result in both cases is a brand new black hole. So here in the picture we can see the two type of gamma ray bursts, which are the short duration burst and the long duration bursts, with respect to the number of bursts and the time, which is in second. So now we have to know what is short gamma ray burst. The event with a duration of less than about 2 seconds are classified as short gamma ray burst. This counts for about 30% of gamma ray bursts. Uh, as I mentioned in the previous slide, in this picture, you can see that the number of counts or the number of bursts of the short gamma ray are much less than the long gamma ray burst, because until 2005 there is no afterglows which have been perfectly or successfully detected. Since then, several dozens of gamma ray burst afterglows has been detected and localized and observed, which are associated with regions of little or no star formation, such as large electric galaxies. And after this type of detections of short gamma ray burst, this detection ruled out a link to massive stars, confirming that short events are physically distinct from long events. So now the broader part, which is the long gamma ray burst. So most observed event is this, which is nearly 70%, and uh, because these events constitute the major of the population, and because they tends to have the brightest afterglows, they have been observed in much greater details than their short counterparts. So, and in many cases, to a core collapse supernova as well, ambiguously associating long gamma ray burst with the deaths of massive stars. So now we will get into our data set. So the primary data, which is collected from the source Bartse catalog, which I mentioned previously, which is also associated with the Compton gamma ray observation. So here we took 1963 rows and 13 columns, which are the 13 parameters, which are the trigger number F1, F2, F3, F4, T50, T90, F64, F256 and which are giving here. So in short, trigger number is defined here as the trigger number is defined here as the burst trigger number. This is the running sequence of number of burst trigger, which is includes cosmic bursts, solar flares, etc., etc. F1, F2, F3, F4 are the fluences of energetic range, which are for different channels. F1 is for channel 1, F2 is for channel 2, and so on, which are defined as the energetic range, which is kilo electron volts. T50 and T90 are the percentage of duration of burst in 1 second. The basic difference between T50 and T90 is the start of the T50 interval defines by the time at which 25% of the total counts are detected. At the end of the T50 intervals, there are near about 75% counts are detected, and in T90, in the initial stage only 5% bursts are detected, and in the tail end 95% of the observations are detected. And the F64, F256 and F1024 MSR, the peak fluxes at 64 milliseconds, 256 milliseconds, and 1024 milliseconds. And H32 is the ratio of F3 and F2, and H3 to 1 is the ratio of F3 and F1 plus F2, and Ft is the total of the fluxes. So now we are getting into the exploratory analysis part. We plotted the histogram for every parameters. Uh, uh, Before the histogram, we can say that before the histogram, we can say that the original data which is collected, there are about nearly 400 missing values, which are cleared, or you can say imputed by the PNN method. Basically, it is called the predictive mean matching method. Basically, predictive mean matching uh, calculates the predicted value of the target variables according to the specific imputed model. So after that, the exploratory data analysis part, where we plotted the histogram of every parameters to know about their distributions and other properties, and we also checked the equivalence of every distribution with the normative test of the non-parametric test, which is called Kolmogorov model test, and verified it with Shapley-Wills test of normality. So here are the exploded histograms of the 13 parameters. Trigger number is basically not needed, but we observe that. So here log F1, log F2, log F3, and log F4 are following a normal distribution. As I mentioned above previously, that Ft is the sum of the F1, F2, F3, and F4. So obviously it is also following normal distribution. F64, F256, F124 is not following a normal distribution, and log T50 is also not following a normal distribution, and log H32 and log H321 is following a normal distribution. So now let's come to the part of the correlation, where we use Pearson correlation to plot to get this correlation matrix. From this correlation matrix, we can say that there is a high correlation between T90 and T50, which is nearly 0.94, and there is a high correlation between T log of H321 and H32, which is nearly 0.94. So H321 and H32 is quite obvious because they are the functions, or you can say the ratios of F1, F2, and F3. But log of T90 and T50 are the time points which are where the burst counts are observed. From the correlation matrix, we can infer that since there is a high positive correlation between T50 and T90, the time interval in which 90% counts is observed is dependent on the time interval in which 50% burst counts are observed. So now let's get into the main part, which is the partitioning part, or you can say the statistical analysis or K-means clustering algorithm. So what is clustering algorithm is given here. Now I'm going to discuss about what we got from the K-means clustering. One of the main motives of this work was to verify the existence of two types of gamma ray burst. We have applied K-means clustering technique to the dataset and obtained some outcomes. The choice of optimal number of clusters is obtained from the elbow plot, which is given here, which is giving here as 2, the optimal number of clusters. After applying the K-means clustering algorithm, we tried to visualize the two clusters with R programming languages, and we got two distinctive clusters, which are 907 and 1055, which is written here. And we also got a table of two clusters with having the and all the parameters which are having the cluster means. Next to next to get an idea of classification of the data, we perform linear discriminant analysis, and the result of the discriminant analysis is tabulated here, where the predicted cluster predicted clusters and the actual clusters are given, which is given in the table format, which is a confusion matrix. So you can say that a total misclassification of 770 data in this part, and 407 true negative values, 270 false positive values, 500 false negative values, and 785 true positive values. So 770 means a total percentage of 43% of misclassification is observed here. So as I uh, mention all the statistical methodologies and all, so we have to know why we are studying this, why we are studying this gamma ray burst. Earth's atmosphere is effective at observing high energy electromagnetic radiation such as X-rays, gamma rays. So these types of radiation would not reach any dangerous levels at the surface during the burst event itself. But if some source of gamma ray burst is near Earth, or some in the near interval of Earth, then gamma ray burst, which is in the few kilopulses with the energy direct toward Earth, will mostly damage life by raising the UV levels during the burst itself. And for a few years thereafter, models show that destructive effects of this increase can cause up to 16 times the normal level of DNA damage. It has proved it has proved difficult to assess a reliable evaluation of the consequences of this on the terrestrial ecosystem because of the uncertainty in biological field and laboratory data. So let's get into the conclusion. So as we conclude, some of the parameters which are following normal, as some of the parameters are not following normal, the time intervals in which 90% of the burst counts are detected is highly positive correlated with the time interval in which 50% of the burst count is detected. From the Kolmogorov-Smirnov non-parametric test and the normality test of Shapiro-Wilks, it is evident that the distribution of the time interval for the percentage of the burst count changes with time. As I mentioned in the beginning of the slide, there that showing at the short burst counts and long burst counts. The short burst counts are kind of a negative skewed graph, and the long burst counts is a kind of a kind of normal distributed curve. Also, from the partitioning method, we can evidently confirm that the data presence of in the data there is a presence of long burst and short burst as the primary type of gamma ray burst. Also, from the linear discriminant analysis, or LDA, we can conclude that there are about 43% of misclassification in the clusters. So here we have used some references which are given here, and thank you. And now we are open to any questions, and me and my co-author Shinjan Chakraborty both are here. Thank you. Hello, sir. Hello. Hello, sir.
Yes.
Is it done?
Yeah.
Okay.
Saurabh. Yeah.
Okay, sorry, sir. It was network problem. Okay,
Yeah.
thank you very much for this nice talk. So now we'll call our next speaker, Dr. Manjit. Dr. Manjit, are you available? Dr. Manjit?
Yeah, I can see Manjit is here. Yeah.
Please unmute yourself. Am I audible to you?
Manjit, we cannot hear you.
Please unmute yourself. Okay, maybe we'll call the next one.
Manjit, I think you might have some issue with your speaker. So I can see that something is blinking from your screen, but it's not, we cannot hear you. Okay, maybe it's, yes, please continue.
Dr. Manjit? Okay, maybe next time
Hello, sir.
we'll listen to him. Okay, okay. Am I audible? Please unmute yourself. Hello, Dr. Manjit.
Yeah, Manjit,
Dr.
I
Manjit.
think you might have some issue with your speaker or your microphone, I guess. So maybe please have a look at it, and maybe we can continue with other speakers, and then you will come.
Yeah, maybe at the end, sir, at the end we'll look into it.
Yeah.
That's
Yes.
better.
Yeah.
So we'll proceed for our next speaker, and our next speaker is Miss Diksha Mangla. Are you there?
Yes, sir, I'm here.
Okay. So let us welcome Ms. Diksha Mangla, and she will be speaking on the topic interpretation of reliability characteristics of a system with preventive maintenance. So, Ms. Mangla, please continue with the
A very
continue with
good
the
afternoon
presentation.
to all of you. Yes, I'm audible, sir.
Yes, yes, you are audible.
Very good afternoon to all of you. Today I'm Diksha Mangla, a research scholar, going to represent the topic the interpretation of reliability characteristics of a system with preventive maintenance on the 16th International Conference MSAST 2022. The outlines of this presentation is abstract system description, transition diagram, mathematical computation, result, conclusion, and the last one is references. The abstract is reliability analysis for a system plays a crucial role to increase the production with less cost of maintenance. For having easy life with correct result, the dependence on machine has been increasing, and for this, it's become too important to have more reliable system. A lot of work has been.
Diksha, excuse
Yes,
me,
sir.
your slide is not visible. So could you please share once again your slides?
Okay, sir. So someone has stopped me to share. It's visible now, sir.
Yeah, it's visible now. Yeah.
So I am going to tell the outline of my abstract is that I am working on a reliable system that importance for maintaining the most profit, and for this the system always fails sometime. So I am going to apply the method of preventive maintenance on my system to get a better result. In the end of this presentation, a graphical result has been plotted to analyze the performance of a system with respect to the failure rate, repair rate, and preventive maintenance rate. The results show that the good maintenance play a vital role to increase the overall reliability of a system. System description: a system made of a two component. In my presentation or in my work, a system is made up of a two component arranged in a series manner. Hence, the failure of any one component resulting into the breakage of a whole system, that is stopping of a whole system. The component B can work with a less efficiency as a degraded state due to the some factor like a lacking of greasing, friction, etc., which undergo preventive maintenance to increase the availability. The component A is present in the direct failure or a repair rate. Here is a system transition diagram. The circle represents the full capacity of a system A, B, in which A and B both are working proper state, proper working. The state is represented by S naught. From AB, it go to the second state S1, where B is present in the degraded form that needs some preventive maintenance with the preventive maintenance beta, and the failure rate or degraded rate is lambda. From S1 to S2, where the B component completely fails, from there it needs a repair that of alpha 1 to go back with the proper working state as 0. Now from S0 to S3, in this state, a component A completely fails with the failure at lambda 2 and the repair rate alpha 2. We can go back to the proper working state A, S3 to S0. This is the transition diagram of this system. Now, mathematical computation, let PIT probability that system in the state of SI, if we let PT denote the probability row vector at time t, the initial condition when the system is in a full capacity as new, that is a state S0 for this problem are P0 that is equal to P naught T, P1, P2, P3. 1 0 0 0, that is a row vector. The differential equation using the transition diagrams are formed here. Differentiation of P naught that is equal to minus lambda 2 plus lambda P naught plus alpha 2 P3 plus beta P1 plus alpha 1 P2. P1 differentiation of P1 is equal to minus beta plus lambda 1 P1 plus lambda P naught. Similarly, differentiation for the P2 and P3 are generated here, where alpha 1, lambda 1 are the repair rate and failure rate. Similarly, alpha 2 and lambda 2 are the repair rate and failure rate respectively. Now, this differential equation is represented in the matrix form P dot AP, where A is a matrix minus lambda 2 plus lambda, beta alpha 1 alpha 2, lambda minus beta plus lambda 1 0 0 0, lambda 1 minus alpha 1 0, lambda 2 0 0 minus alpha 2. For finding the MTTF, that is mean time to system failure, that is the time working for a system going from a good state to the completely failure state. It represented by MTTF. It is equal to P at the time 0 minus Q inverse matrix 1 1, where Q is represented minus lambda 2 plus lambda, lambda beta minus beta plus lambda 1. It is obtained for removing the row vector and the column vector, third row and the fourth row from the matrix A and taking the transpose of this. By solving the equation number 2, I get the MTTF result beta plus lambda 1 plus lambda divided by lambda 2 plus lambda into lambda 1 plus beta lambda 2. In the similarly, for the availability of our system, we've put the AP is equal to 0. By solving AP is equal to 0 matrix, we get the probabilities P naught, P1, P2, P3. In our system, we have a two states S2 or S3 which are present in the complete failure state, and we know the availability is dependent upon the working state. So I am taking the working state S0 and S1. So I am finding the probability of the state S0 and S1, that is P0 and P1 at the time infinity. By solving AP is equal to 0, we get the result P0 at infinity beta 1 plus lambda 1 alpha 1 alpha 2 divided by beta plus lambda 1 alpha 1 lambda 2 plus alpha 2 plus alpha 2 lambda alpha 1 plus lambda 1, and P0 P1 lambda alpha 1 alpha 2 divided by beta plus lambda 1 alpha 1 lambda 2 plus alpha 2 plus alpha 2 lambda alpha 1 plus lambda 1. These are the result and conclusion. I have the two expression, that is the MTTF, and the second one is P naught availability A infinity P naught P1. By in these two factors, we are getting the different values of alpha 1, alpha 2, lambda 1, lambda 2, lambda, and beta. I am plotting the result by fixing all other parameters except lambda 2 and alpha 2, that is a failure rate and the repair rate. Other parameters are in these two expression MTTF and availability are fixed, but lambda 2 and alpha 2 are variable. When we increase the lambda 2, that is a failure rate is increasing of our system, so the working of a system is decreasing. Mean time to system failure is decreasing, as you show in a figure 1. Figure 2, availability. As the repair rate of any system is increased, of course, the availability of a system is also increased. That is shown in the figure 2. Conclusion, in this study, we developed the expression for the MTTF and the system availability for a two-component series system. Graph was plotted to show the effect of failure repair rate on important measure of system effectiveness. The graph showed that failure rate is very important, particularly in decreasing mean time to system failure, whereas the repair rate helps to increase the availability of the system and affected the overall performance of the system. Some of the references are used here. Thank you. Sir.
Okay, thank you.
Thank you, sir.
This nice talk. So, any question from the audience? Okay, if there is no question, just I have one query.
Yes, sir.
Can you just tell me, is there any application of your work?
Yes, sir. Actually, sir, I am working on the reliable system. I will know that most of the work are dependent on the industry, and industry is made of machines and the system. If the machine will stop, your work will definitely stop. So we can't afford such type of losses in the industry work. So we need to proper work of our machine, and for this, the machine should not stop. So I am going to give the preventive maintenance, like greasing of a machine parts or a corrective maintenance also, so that our work can go properly without any stoppage or without any breakage or without any loss. Definitely.
Okay, thank you for this talk. Okay, now you can
Thank you,
leave.
sir.
Now we'll call our next speaker, Mr. Suman Vuyan. Are you available? Are you online?
Sir, am I audible?
Yes. Okay.
Yes, sir.
Okay. So let us welcome our next speaker, Dr. Suman Vuyan, and she'll be speaking on the topic mathematical study of shear thinking nature of PHP flow through a circular pipe by Hesselbuckle fluid model. So please present your work.
Sir, is my screen visible?
Yes, it's visible. It's visible. So you can make it full screen.
Okay, sir.
You can just press F5.
Sir, is it happening?
Yeah, it's not full screen, but you can present. No problem.
Okay, sir.
Okay, please present your work.
So a very good evening to one and all present here. Myself, Suman Bhuya. Firstly, I'm very thankful to the organizers to give me this opportunity. Today, I'm going to give my presentation on my research work titled A Mathematical Study of Shear Thinning Nature of Pitch Puree Flow Through a Circular Pipe by Herschel-Bagley Fluid Model under the supervision of Dr. Kamal Devnath, HOD of the Department of Mathematics, the Assam Royal Global University, Guwahati. So, here is the outline of my presentation that includes abstract, introduction, objective of the paper, mathematical formulation, method of solution, then results and discussion, conclusion, scope for future work, acknowledgement, then references. Then coming to the abstract of the paper, the non-Newtonian shear thinning nature of flow for pitch puree through circular pipe due to pressure difference is investigated here. As the fluid product, that is pitch puree, contains yield stress, so appropriate Herschel-Bagley fluid model is employed here to study the flow behavior. Coming to the introduction part, as we all know, pitch is one of the temperature climate fruit produced worldwide. Yes,
Suman, sorry to interrupt you. Your slide is not moving.
not moving, sir.
Yeah, could you please go to the slideshow mode? On the top, you can see slideshow.
Slideshow.
On the left, yes, slideshow. And then from the beginning. On the left, could you go to the left at the beginning?
From beginning, yes, sir.
Yes.
Sir, is this visible now?
Not yet. Could you please press once again?
So,
From the beginning?
so from the beginning.
Yes, from the press there.
Sir, now?
F5. You press F5. F5.
F5.
Huh?
Sir, I have pressed the F5. Sir, now is this visible?
Yeah, it's visible, but your slides are not moving. Could you please go to the next slide? Yeah, it's now coming. Okay, please continue. Yeah.
Okay, sir. So coming to the introduction part, the peach is one of the temperature climate fruit produced worldwide. It contains complex nutritive and biologically active substances. Peaches also called as fruit of calmness as it acts as good stress reliever. There are a lot of health benefits of peach. Here we have included some of them. Firstly, lutein and zeaxanthin help to protect the retina and lens of eyes. Then potassium regulates the blood pressure. Then also vitamin A and vitamin C improve skin health, etc. Then the objective of the paper. The present investigation aims to study mathematically the non-Newtonian shear-thinning nature of flow for peach puree through circular pipe due to pressure difference and to study the flow behavior. Coming to the mathematical model, many scientists may often use the power law fluid model, the Herschel-Buckler fluid model, also the Bingham model. Here, due to the yield stress, we have used the Herschel-Buckler fluid model to study the flow behavior, and also the stress component in cylindrical coordinate system in the model is given by equation 1, and the term has usual meanings. Then, as the peach puree flow exhibits yield stress, so appropriate Herschel-Buckler fluid model is employed here, as I have already told. Here arbitrarily we have taken the length 60 meter, radius 0.05 meter and the pressure difference 1 kilopascal. So here is the geometry of the fluid flow. The flow is in the direction of the z-axis. Here small r is the radius. Also the velocity decreases with the increasing values of the radius. Here the shear stress increases. Also, as you can see the plug flow region, this is the region to a certain point the fluid flows in the solid form. So this is region where the solid form happens. So this is called the plug flow region. So coming to the method of solution, we have analytically solved this equation as you can see in the slide. So here we have evaluated the volumetric flow rate, the shear stress, shear strain, then also the average velocity, where you can see the phi, there phi is the ratio between the yield stress and the wall stress. Then coming to the results and discussion part, here the rheological parameters of peach puree used for computation has taken from the table 5.1. Here in the last column, N is the flow index and the second last column, K is the consistency coefficient and sigma naught is the yield stress. Here you can see that with the increasing values of N, the yield stress and the consistency coefficient decreases. In the second table, that is the plug velocity for peach puree, where VZP is the plug velocity. Here also, with the increasing values of N, the plug velocity decreases. Also, the arising values of the temperature, the yield stress and the consistency coefficient also decreases. In the third table, this is the velocity in the deformed region for peach puree. Here, if we take any value like for N 0.360, you can see in the slide that the value of R increases. Also, the velocity in the deformed region, that is Vz, decreases and tends to 0. Coming to the conclusion part, the design of transport system of fluid fruit products mainly depends on the type and description of flow characteristics of the product, and as such the obtained results will be beneficial for product development, design and evaluation of manufacturing processes in food industry. Scope of future work. Due to the wide range of engineering and food science applications, there is plenty of scope to expand this study. As we have taken the peach puree, so as it exhibits the yield stress, we have taken the Herschel-Buckler fluid model. Also for similar fruit or vegetables, we can use this model. Coming to the acknowledgement part, so we are very grateful to the Department of Mathematics, the Assam Royal Global University Guwahati, for providing us all the necessary research facilities to carry out this research work. So here is the references we have gone through to do this project work. Thank you so much.
Thank you, Ms. Manami, for this. Thank you for this nice talk. And is there any question from the audience side? Oh, I think she left.
No, sir, I'm
I
there.
think. Okay, okay, you are there.
Yes.
Okay. Is there any question from the audience side? If there is no question from the audience side, let us thank the speaker again. Thank you.
Thank you,
So
sir.
now you can leave.
Okay, sir.
Now we call our next speaker, Miss Manami Bera. Are you there?
Yes, sir.
Okay. So let us
Hello. Am
welcome.
I audible, sir?
Yes, yes, you are audible.
Okay.
So let us welcome our next speaker, Dr. Manami Bera from West Bengal, India, and she'll be speaking on the topic an identity involving generalized skewed derivations acting on multilinear polynomials in prime rings. So the okay, you can present your work.
Sir, my
Okay.
screen is visible or not?
Yes, it's visible.
Okay. Good afternoon, everyone. First of all, I would like to thank the organizers for giving me this opportunity. And today I will talk about an identity involving generalized Q derivations acting on multilinear polynomials in prime rings. So, ring derivation is a branch of algebra in which we study about the structure of an additive map as well as the structure of a ring by analyzing some functional identities which involves additive maps. And these type of additive maps are like derivations, Q derivation, generalized Q derivation, X generalized derivation, alpha beta derivation, and so on. In this work, we have tried to find out the structure of some generalized derivations which satisfies a functional identity on a prime ring. And these are some important notations which I have used so many times in the throughout the work. And I denoted R as associative ring, Z as center of R, U as Itumi quotient ring of R, C as extended centroid of R, and commutator of X and Y is denoted like this in the third bracket and defined as xy minus yx for all xy in R. And f of r is the set of all evaluations of the polynomial f of x1 x2 xn in R, which is defined in this way where gamma sigma is belongs to the center. And s4 is the standard polynomial identity in four variables, which is defined in this way. And here minus 1 power sigma is either plus 1 or minus 1 depending upon sigma is even permutation or odd permutation in the symmetric group S4. Now, these are some definitions which we need to know for the work. An additive map D defined on R is called derivation if D satisfies D of xy is equals to dxy plus xdy for all xy in R, and if there exists some element A in R such that D of x is equals to commutator of A and x, then D is called inner derivation, otherwise D is called outer derivation. And D is called skew derivation if D satisfies D of xy is equals to D of x into y plus alpha x into dy, where alpha is some automorphism on R. And an additive map f on defined on R is called generalized derivation if f of xy is equals to fxy plus x dy, where d is some derivation of R. And from the inner derivation definition we got fx equals to the form ax plus xb for some ab in the ring R. And f is called generalized q derivation if f of xy is equals to fxy plus alpha x dy, where d is some skewed derivation of R and alpha is some automorphism in R. And in this case this d is called associated skewed derivation and this alpha is called associated automorphism in F. Let S be a subset of R, and a mapping xi is said to be commuting on S if commutator of xi x and x equal to 0 for all x in S, and a mapping xi and the mapping xi is said to be centralizing on S if commutator of xi x and x is belongs to the center. Now this is an example. Let R is the ring of matrices where A, B, C, the element of this matrix comes from Z2, where Z2 is the the group of integers modulo 2, and we have defined F like this way and D in this way. Then from this definition we can easily check that d of xy is equals to dxy plus x dy. That means d is a derivation, and from this definition also we can check that f of xy is equals to fxy plus x dy. That means f is a derivation. But if we calculate f of xy, then we can get that f of xy is not equals to fxy plus xfy. That means f is a generalized derivation, but it is not a derivation. So from this example we can easily say that every derivation is a generalized derivation, but each and every generalized derivation may not be a derivation. Now let R be a non-commutative prime ring. Then in 1957, E.C. Posner proved that commutator of du and u belongs to the center. If this happens, then either d equal to 0 or R is commutative. Here d is the derivation. So in this way, he found out a relation between derivation and prime ring, and since then this type of work has been started. So, and in 1993, M. Bracer extended the previous result, and they studied if d1u minus u d2u belongs to the center, where d1 and d2 are two derivations on R, then they proved that both of d1 and d2 will be equal to 0. In 1998, T.K. Lee and W.K. Hsu studied the previous same condition, but they replaced u with a non-central multilinear polynomial f of u1, u2, un. That means they proved that if d1x minus x d2x belongs to the center, where x is a non-central multilinear polynomial over C, and d1 d2 are two derivations of ring R, then they proved that either d1 d2 both will be 0, or d1 will be equal to minus d2, and f square is central valued except when characteristic of r equal to 2. And they proved if characteristic of r equal to 2, then r satisfies S4. In 2013, these authors studied the identity T1 of U and T2 of U equal to 0. Where here they also have taken U as a multilinear polynomial which is non-central over C, and T1, T2 are generalized derivations. Then they proved one of the following results, that is either T1 x will be equal to xa, T2 equal to cx with AC equal to 0, or f square is central valued on R, and t1 equal to ax, t2 equal to xc with ac equal to 0, or f square is central valued on R, and t1x will be equal to ax plus xb, t2x equal to cx plus xq with a plus b into c plus q equal to 0. In this way they have described all possible forms of these generalized derivations t1 and t2. So, getting inspired by the previous works, our intention is to discuss the result that if R satisfies the identity T1U T2U equal to T1U minus U T2U, here we also have taken U as the non-central multilinear polynomial over C, f of R1, R2, Rn, and T1 and T2 are two non-zero generalized Q derivations on R. Then we have the following results, that is either t1x will be equal to xa, t2 equal to cx with a plus 1 into c equal to a, or t1x equal to ax, t2x equal to xc with a plus 1 into c equal to a, or f square is central valued on R, and any one of the following results will hold. So in this way we also have described all possible forms of these two non-zero generalized q derivations t1 and t2. And to study the works, we have used some following facts. For any prime ring R, Itomi quotient ring U, and a two-sided ideal I of R, in 1988, T.K. Lee proved that every generalized derivation of R can be uniquely extended to U. With this hypothesis, in 1998, C.L. Chuang proved that I, R, and U satisfy the same generalized polynomial identities with coefficients in U. And let MMC M greater equals to 2 be the ring of all M cross M matrices over an infinite field C. In 2012, these authors proved that if A1, A2, and AK are not scalar matrices in MMC, then there exists an invertible matrix P in MMC such that any matrices PA1 P inverse, PA2 P inverse, and PAK P inverse have all non-zero entries. We have taken help of these three facts, and these are some references which were used. Oh, and thank you.
Okay, thank you very much for this nice talk. So, any question from the audience side? Okay, if there is no question from the audience side, let us thank the speaker again. Thank you very much for this interesting talk. Hope that it will be useful
Thank you,
for
sir.
other researchers also. Let us call our next
Sir,
speaker, and our next speaker is Dr. Pompi Das. Are you there?
Yes, sir. As I have some issue with my Gmail account, I'm use my friend account, Suman Bhuya.
Okay, fine. Okay,
Okay,
so
sir.
let us welcome our next speaker, Dr. Pompi Das, and she will be speaking on the topic behavioral study of carrot with existing shear thickening nature of flow past a cylindrical pipe by power law fluid model. So you can present your work now.
Sir, the screen is visible or not?
Yes, your screen is visible, but you just open the slide first. Yeah,
Yes,
you
sir.
just
Yes.
open your presentation. Yes,
So
now
is it clear?
screen is not changing. You just click on, oh, okay, change your on time slide, you change. Next slide you go. Okay, fine. Now you can start. Okay,
Okay,
it's
sir. Good evening, one and all present here. I am Pompidas, MSc Mathematics from Royal Global University. Today, I am going to give my presentation on the topic, a behavioral study of carriageways exhibiting shear thickening nature of flow past a cylindrical pipe by power law fluid model. Here is my outline of the presentation. Abstract, introduction, mathematical formulation, method of solution, result and discussion, conclusion, scope for future work, acknowledgement, and references. Here is my abstract. Carriageways exhibiting shear thickening nature of flow under certain prescribed conditions are taken into consideration in this study. The fluid flow through a cylindrical pipe due to pressure difference is studied by power law fluid model. The graphical representation of velocity profile for different values of consistency coefficient and flow index of carriageways are plotted with the help of programming code utilizing MATLAB to study the flow pattern. Here is my introduction. As we know, carrot is a type of plant having different variety. It is a root vegetable, often claimed to be a perfect health food. It is crunchy, tasty, and highly nutritious, and it is rich of source of vitamins, protein, carbohydrate, fat, iron, potassium, and beta carotene. As we know, drinking carrot juice has a lot of health benefits, some of which are listed below. Presence of antioxidant and fiber keeps the heart healthy. Vitamin A and E present it in help to boost our health, protect from infection, and keep eyes healthy. My objectives of the project is the design of transport system of fluid products mainly depend on a type and description of flow characteristics of the product, which is beneficial for product development, design, and evolution of manufacturing processes in food industry. The present study aimed to examine the flow development mathematically for the carriages inside a cylindrical tube and to investigate the effects of consistency coefficient and flow index on the velocity profile. Here is my mathematical model. Here I used a power law fluid model. The power law fluid model is considered in this study as in given by tau equal to k gamma dot n, where tau is a shear stress, k is the consistency coefficient, and gamma is a shear rate, and n denotes the flow behavior index. The constant of k and n are required to characterize the flow behavior. Here we use three types of fluid. First one is shear thinning, which is also called pseudoplastic, where values of n lies between 0 to 1. And the second one is Newtonian, and the third one is shear thickening, which is also known as dilatant fluid, where the value of n greater than 1. Here is my mathematical formulation. The flow of carriage juice through a cylindrical pipe due to pressure difference is considered. The shear thickening nature of flow of carriage juice under certain prescribed conditions is investigated by employing power law fluid model. The cylindrical tube under consideration is of length 10 meter, radius 0.015 meter, and pressure differences are 10 kilopascal. To obtain the governing equation of fluid motion, the following assumptions are considered. The flow is incompressible, laminar, and steady. Gravity is negligible and isothermal in condition. The flow is symmetry in theta direction and flow are fully developed. The flow direction is in z direction, which is a function of r. Here is the mathematical formulation. And we solve all of the equation analytically. And here where we get tau w is wall stress and tau rz is shear stress, and vz is velocity under z direction, and this is average velocity, and q is volumetric rate flow. And now moving to the result and discussion. The graphical representation of velocity profile for different values of consistency coefficient and flow index of carriage juice are shown in table 5.1, are plotted with the help of programming code utilizing MATLAB to study the flow pattern in figure 5.1 to 5.5. Here we see the smooth pattern of flow for variation of consistency coefficient and flow index parameter is also noticed. The parabolic nature of flow pattern is observed in the obtained velocity profile. The flow development of the cylindrical tube is diminishing with the reducing values of consistency coefficient K, and the variation of flow index of parameter and doesn't affect the flow pattern significantly, as we see in the graph. And here is my conclusion. The transportation of fluid in a chemical and process industry over long distances from storage to various processing units are carried out by pumping the fluids through pipes. The behavior study of flow pattern is much essential to facilitate the optimal design and layout of flow networks, which may represent a significant part of the total plant cost. The velocity profile established in a given flow situation strongly influences the heat and mass transfer processes. And we have many scope for future work, and there are lots of scope to extend this work for further research due to the diversified application in engineering and food sciences. Non-Newtonian fluid flow of different fruit and vegetable product can also be studied with the help of same fluid model. We are thankful to the Department of Mathematics, the Assam Royal Global University, Guwahati, for providing us all the necessary research facilities to carry out this research work. And here is the references I had gone through. Thank you.
Thank you very much for this nice talk. Is there any question from the audience side? Okay. If there is no question from the audience side, let us thank the speaker again. So you can leave now. So let us call our next speaker, and the next speaker is Miss Poonam Kumari. Are you there?
Yes, I'm here.
Okay. So let us welcome our next speaker, Miss Poonam Kumari, and she will be speaking on the topic an approximation method to solve non-linear programming problems.
My screen visible, sir?
Yes, it's visible.
Good afternoon, everyone. I am Poonam Kumari, Department of Mathematics, Patna University, Patna. The topic of my paper is an approximation method to solve non-linear programming problems. This is outline of my paper. Non-linear programming problems, definition and mathematical formulation, solution of the non-linear programming problem, proposed method, algorithm for the proposed method, numerical examples, comparison of the numerical results, conclusion, and finally references. Non-linear programming problem, definition and mathematical formulation. The problem of optimizing a numerical function of one or more variables subject to constraints on the variables is called an optimization problem. The numerical function to be optimized is called the objective function. If any of the functions among the objective and the constant function is non-linear, the problem is called a non-linear programming problem. The general non-linear programming problem can be written mathematically as follows. Minimize f of x subject to gi of x greater than equal to 0, hg of x equal to 0, where x is a column vector consisting of x1, x2, xn, and f, gi, and hg are differentiable functions. Solution of the nonlinear programming problem. Suppose that a feasible solution to nonlinear programming problem 1 is available at the kth iteration. We linearize all the nonlinear functions around xk using Taylor series and get the approximation represented by equation 2, that is by this equation. We also impose additional restrictions represented by equation 3, that is by this equation. And using the above approximations and the additional constants, we solve the resulting linear programming problem represented by equation 4, that is by this equation, where MLK are some suitably chosen positive numbers. Proposed method. A starting feasible trial solution xk is taken, and all the nonlinear functions are linearized around xk using 2. Some positive numbers MLK are chosen, and the nonlinear programming problem 1 is reduced to the approximating linear programming problem 4, shown already in the slide. The resulting linear programming problem 4 is solved to get an optimal solution xk plus 1. If xk plus 1 is feasible for the given nonlinear programming problem, the approximation procedure given by 2 and then solving the approximating linear programming problem 4 is repeated until no significant improvement occurs in the objective function. On the other hand, if xk plus 1 not feasible for the given nonlinear programming problem, the approximating linear programming problem 4 is solved by reducing the values of MLK to get a feasible solution to given nonlinear programming problem. The process continues until no significant improvement occurs in the objective function. Algorithm for the proposed method. There are 4 steps in the method. Step 1, find a feasible point xk for the given nonlinear programming problem and set k equal to 0. Step 2, solve the approximating linear programming problem 4 for some suitably chosen positive numbers MLK. Let an optimal solution be xk plus 1. If xk plus 1 satisfies the given constant, that is these two constants, we go to step 4. If xk plus does not satisfy these constants, we repeat step 2 with the reduced value of MLK to get a solution satisfying these constants. If repetition of step 2 for the given xk does not yield an xk plus 1 satisfying these constants, then restart the algorithm with a different feasible point. Step 4, if f of xk minus f of xk plus 1 mod of this is less than epsilon, then where epsilon is a prescribed tolerance, terminate. The point xk plus 1 is taken as a solution to given nonlinear programming problem. If inequality 5 is not satisfied, then replace k by k plus 1 and go to step 2. Now we come to numerical examples. First example is use the approximation method to solve this nonlinear programming problem. Problem is written here. We take the starting feasible point as the column vector consisting of half and the convergence limit in step 4 as 0.3. To solve this, we first take a starting feasible solution, which is given as x naught. This column vector consists of 2 elements, 1 by 2, 1 by 2. Let m1 not equal to 1 and m2 not equal to 2 for the bonds. Then the linear programming problem to be solved is represented here, where we have taken the value of m1 not equal to 1 and m2 not equal to 2. If we solve this linear programming problem, the optimal solution is derived as column vector consisting of minus half and 5 by 2. This point does not satisfy the constant of x is equal to 0, and so a reduction in the values of m1 naught and m2 naught is necessary. Let us half the bonds, that is take m1 naught is equal to half, m2 is equal to 1. Previously we had taken m1 is equal to 1 and 2. Now we are reducing the values to half and 1. Then we solve the linear programming problem represented here. The problem in this problem consists of the values of m1 naught and m2 of s 1 by 2 and 1. The optimal solution to this problem is the column vector consisting of 0 and 3 by 2. This point also does not satisfy the given constant g of x is equal to 0, and so a reduction in the values of m1 naught and m2 naught is necessary. Let us half the bonds, that is take m1 naught equal to 1 by 4 and m2 naught equal to half. Then we have to solve the linear programming problem represented by these equations. The optimal solution to this problem is the column vector consisting of 1 by 4 and 1. It is a feasible solution to the given nonlinear programming problem. Therefore, x1 is equal to the column vector consisting of 1 by 4 and 1 is the new starting feasible point. Now, if we calculate the mod of f of x0 minus f of x1, we get its value as 0.75, which is greater than 0.3. So, we repeat the process with a new feasible point, which consists of column vector having 1 by 4 and 1 as its elements. Now we take m1 not equal to 1 by 4, m2 equal to 1 by 2. Then the linear programming problem to be solved is minimize f of x subject to these constants. The optimal solution to this problem is the column vector consisting of 0 and 9 by 8. This point does not satisfy the constant, and so we again reduce the values of m1 naught m2 naught. Now we take these values at 1 by 8 and 1 by 4. The new linear programming problem to be solved is represented here. The optimal solution to this problem is the column vector consisting of 1 by 8, 7 by 6. This point also does not satisfy the constant, and therefore we again reduce the values of m1 at m2 naught. Now we are taking the value of m1 naught at 1 by 16 and m2 naught equal to 1 by 8. The new linear programming problem to be solved is like this. The optimal solution to this problem is the column vector consisting of 3 by 16 and 9 by 8. It is a feasible solution to the given nonlinear programming problem. Therefore, x2, which is a column vector consisting of 3 by 16 and 9 by 8, is the next feasible solution to the given problem. Now, mod of f of x0 minus f of x1 minus f of x2 is 0.18 and its value is less than 0.3. Therefore, the process is terminated and the point x2, which consists of 3 by 16 and 9 by 8, is taken as the optimal solution to the given nonlinear programming problem, and the value of f of x2 is minus 0.93. It can be seen that the exact optimal solution is the column vector consisting of 0 and 1, and the value of f of x star is minus 1, where our value derived here is minus 0.93. Example 2, we use the approximation method to solve this linear programming problem, and the starting feasible point is taken here as a column vector consisting of 5 by 2 and 1 by 2, and the convergence limit in step 4 is 0.2. To start with, we take a starting feasible solution, which is given as the column vector consisting of 5 by 2 and 1 by 2. Let us take m1 naught equal to 1 and m2 equal to 2 for the bonds MLK. Then the linear programming problem to be solved is represented here. Here are two constants. First one is this, second one is this. The optimal solution to this problem is the column vector consisting of 7 by 2 and 0. This point does not satisfy the constant g is equal to 0, and so a reduction in the values of m1 naught and m2 naught is m1 naught and m2 naught is necessary. Let us half the bonds from m1 at m2 naught, that is take m1 is equal to 1 by 2, m2 is equal to 1. Then we have to solve the linear programming problem represented by this. And the optimal solution to this problem is the column vector consisting of 3 and 0. It is a feasible solution to the given nonlinear programming problem. Therefore, this column vector, which consists of 3 and 0, is the new starting feasible point. Now, mod of f of x0 minus f of x1 is 1, and this is greater than 0.2. So, we repeat the process with a new feasible point x1, which is column vector consisting of 3 and 0. Now we take the value of m1 naught equal to 1 by 2, m2 is equal to 1. Then the linear programming problem to be solved is represented here. The optimal solution to this problem is a column vector consisting of 3 and 0. It is a feasible solution to the given nonlinear programming problem. Therefore, x2, which is a column vector consisting of 3 and 0, is the next feasible solution to the given problem. Now, mod of f of x1 minus f of x2 is 0, which is less than 0.2. Therefore, the process terminated and the point x2 consisting of 3 and 0 as its elements is taken as the optimal solution to the given nonlinear programming problem, and the value of f of x2 is minus 3. It can be seen that the exact optimal solution is also the same which we have derived, and the value of f of x star is also minus 3, and the optimal solution obtained by this method is also the same. Comparison of the numerical results. This table shows the comparison between the proposed method and other methods. The optimal solution obtained by proposed method is 3 by 16, 9.8, and optimal value is minus 0.93, whereas the value of optimal solution obtained by Sarup is 0, 1, and optimal value is minus 1. Similarly, for second example, the value obtained by proposed method, optimal solution is 3, 0, and optimal value is minus 3, whereas the optimal solution obtained by Kelly is 47 divided by 15, and optimal value is minus 3.33. It can be seen the results obtained by proposed method are approximately the same as those
Sorry for
obtained
the
by other.
interruption. Hello. Please bind up your work because we have limited time. Okay.
Okay, sir. Okay, sir. The values of the numbers MLK greatly influence the success of the algorithm. A completely new linear programming problem has to be solved at each station. This makes the method time-consuming. Therefore, the method in general is useful for non-linear programming problems with many variables, and when there are only a few non-linear constants in addition to the linear ones. These are the references. Thank you.
Thank you very much for this nice talk. So, is there any question from the audience side? If you have any question, you can ask. Okay, if there is no other question from the audience side, let us thank the speaker again. Thank you very much for this nice talk. Okay, you can leave now. So let us welcome our next speaker, Mr. Kavindra Goswami. Kavindra, are you online?
Yes, sir. I am online. Am I audible?
Yes. So let us welcome our next speaker, Mr. Kavindra Goswami, and he will be speaking on the topic a new notion of entropy of a map in biotopological dynamical system.
Sir, is my slide visible?
1 second, I cannot see your slide. Yes, it's coming.
Okay, sir.
Yes, you can make it full screen. Okay, no, otherwise, okay, you can present. Yeah.
Okay, sir. Good afternoon, everyone. Myself, Kavindra Goswami, Assistant Professor, Department of Mathematics, Goalpara College, Goalpara, Assam. So today, title of my talk is a new notion of entropy of a map in biotopological dynamical systems. So this talk is based on our paper, joint work, entropy of a pairwise continuous map in non-nuclear pairwise compact biotopological dynamical systems, with Dr. Santanu Acharya, Assistant Professor, Department of Mathematics, Guwahati University, and Professor Hemanta Kumar Homa, Department of Mathematics, Guwahati University. Entropy is one of the oldest and widely accepted measures of complexity. The term entropy was formed from two Greek words, en, which means in, and trop, which means transformation. Initially, the term entropy was used in many fields: physics, information theory, and so on, with different meanings. Kolmogorov introduced the concept of entropy in dynamical systems. After that, many researchers work on entropy. It is evident that if the entropy of a dynamical system is positive, then the system becomes chaotic. Topological entropy has been applied in diverse branches, from knot theory to billiard balls, DNA sequence analysis to information theory. In recent years, it becomes a very active area of research in topological dynamical systems. Asarji et al. Introduced bitopological dynamical systems to study dynamical systems with respect to two topologies. Also, Asarji et al. Introduced the notion of entropy in bitopological dynamical systems. In this paper, we develop a new idea regarding entropy in bitopological dynamical systems. Introduction. Kelly introduced the concept of bitopological space. Later, bitopological space was extensively studied by many researchers from various branches, and studies is still going on. Here are some recent papers: Asarji and Tripathi Asarji et al., Fletcher et al., and so on. The term entropy was from two Greek words. We have already explained this in abstract. So now, Adler et al. Introduced the concept of topological entropy in a compact topological space as an invariant for continuous mapping. Later, many researchers extended the notion of entropy into reference spaces. So, since biotopological dynamical system is a new area of dynamical system, so there is only one known definition of entropy, which is introduced by Asarji et al. So now, but in that paper, they have introduced the entropy in a pairwise compact, weakly pairwise compact biotopological dynamical system. So in this paper, we will introduce entropy in a non-weakly pairwise compact biotopological dynamical system. So here are some preliminary definition. X plus x on which are defined two arbitrary topologies tau1 and tau2 are called a biotopological space. And the structure is denoted by x, tau1, tau2. A biotopological space X together with a map F is called a biotopological dynamical system. A cover curl U of a biotopological space X tau1 tau2 is weakly pairwise open if U is subset of tau1 union tau2 union set U intersection V where U is non-empty as well as not equal to X below in tau1 and V non-empty and V is non-empty and is not equal to the X in tau2. U intersection tau1 contains a non-empty set and U intersection tau2 contains a non-empty set. A biotopological space X tau1 tau2 is weakly pairwise compact provided every weakly pairwise open cover of X has a finite subcover. So here are our main work. So we introduce entropy in non-weakly pairwise compact biotopological dynamical system. So here we by n we take the set of we denote the set of non-negative integers, by z the set of integers, and r the set of real numbers. So let x comma f be a biotopological dynamical system. Here x tau1 tau2 is a biotopological space and f from x to x is a pairwise continuous map. Let x tau1 tau2 be a non-nuclear pairwise compact biotopological space and kappa of x denotes the set of all countable number of non-empty weakly pairwise compact subsets of x such that for each k in kappa of x is either minus invariant or invariant for the map f. For k in kappa x and for weakly pairwise open cover curly u of x, let nk of u denotes the number of sets in a subcover for k of u with minimal cardinality. Also let lk of u equal to log nk of u. For any two weakly pairwise open cover curly u and curly v of x, we define the zone by curly u zone curly v is equal to u union v, where u in u and v in v. Then u zone v is also a weakly pairwise open cover of x. A weakly pairwise open cover of curly u is said to be a refinement of a weakly pairwise open cover v. Curly v denoted by curly u is a refinement of curly v if every member of curly u is a subset of at least one member of curly v. Here are some basic properties. For any weakly pairwise open cover curly u of x, nk of curly u greater than or equal to 1 and therefore lk of u greater than or equal to 0. Property 2, lk of f inverse of curly u less than or equal to lk of u. Property 3, for any weakly pairwise open cover curly u of x, lk of n for any weakly pairwise open cover curly v, lk of u curly u and curly v is less than or equal to lk of curly u plus lk of curly v. Also, for a weakly or a pairwise continuous map f n for any two weakly pairwise open cover curly u and curly v of x, f inverse of curly u join curly v is equal to f inverse of curly u join f inverse of curly v. Again, if u and curly v are two weakly pairwise open covers of x, such that curly u is a refinement curly v, then nk of curly v is less than or equal to nk of curly u, and also lk of curly v is less than or equal to lk of curly u. Next, property 3.6, let x comma f be a non-weakly pairwise compact biotopological dynamical system and k in kappa of x. Then for any weakly pairwise open cover curly u by x, the limit n tends to infinity 1 by n lk of join I goes to 0 to n plus 1 f raised to the power minus I of curly u is exists and is finite. Using this property 3.6, we define the notion of entropy. So here x comma f is a non-nuclear pairwise compact biotopological dynamical system and k in kappa of x. The entropy of f on k relative to the weakly pairwise open cover curly u is defined as E of f comma curly u comma k is equal to limit n tends to infinity 1 by n lk of join I goes to 0 to n plus 1 f raised to the power minus I of u. Property 3.7, for any weakly pairwise open cover curly u of x, E of f comma curly u comma k is less than or equal to lk of u. Then we define the entropy of a map f, pairwise continuous map f on k as, supremum over all weakly pairs open cover Kali U of X of entropy of F with respect to the weakly pairs open cover Kali U on K. 3.8. Let X, F be a non-nuclear compact by topology dynamical system and K1, K2 in kappa X such that K1 is a subset of K2. Then entropy of F with respect entropy of F on K1 is less than or equal to entropy of F on K2. Then we define the entropy of a map F. Now, if kappa of X is non-equal to 0, then we define entropy of F as supremum of all K in kappa X of entropy of F on K. And if kappa of X equal to 0, we define entropy of F as equal to 0. Here are some fundamental properties of entropy. If F is a plus invariant map, the entropy of F is 0. And if F is the identity map, then also entropy of F is equal to 0. And for any positive integer K, entropy of F to the power K is equal to K into entropy of F. Neural activity of human brain. So, from medical literature, after reaching a signal to the brain for performing a certain task, only few neurons become activated to perform the related neural activity. On the other hand, most of the neurons remain inactive to the specific task. So, thus, we suspect that the neural behavior of the human brain is instigate us to think that the neural activity may not be related to weakly pairwise compactness. Thus, we suspect that the neural behavior of the human brain is related to, maybe somehow related to non-nuclear pairwise compact biotopological dynamical system. And so, possible connection between neural activity of human brain and entropy of a map in non-nuclear pairwise compact biotopological dynamical systems may be found in future. Conclusion. In this paper, we introduce the notion of entropy in non-nuclear pairwise compact biotopological dynamical systems. From the discussed properties of our definition of entropy, it can be said that our definition of entropy has the potential to measure the complexity of a non-nuclear pairwise compact biotopological dynamical system. So in this scenario, we need a deep research in this area. Also, we discussed the possible connection between neural activity of human brain and our defined notion of entropy. So here are some references I have been going through. Thank you.
Okay, thank you very much for this nice talk. So, any question from the audience? If there is any question, you can ask, please. Okay, is there no? Okay, yeah. Yes, please. If you have any question, you can ask. Okay, if there is no other question from the audience side, I have one query to the speaker. Hello, Mr. Kavinder?
Yes, sir, I am on.
Oh, you are working in biotopological dynamical system, right?
Yes, sir.
So, okay, are you a student of Dr. Santanu Acharjee?
Yes, sir.
Okay. Very nice. I saw his work. Very nice.
Hi, sir.
So,
Thank you,
what
sir.
are the possible applications of your work?
Sir, we are thinking to apply it in a brain. Actually, I am working on neural activity and related to non-nuclear pairwise compact biotopological dynamical system right now with Santanu Acharjee, sir.
Okay. Thank you.
Thank you, sir.
Thank you. Thanks for this nice talk. So let us welcome our next speaker, Dr. Hemanta Kalita from Assam, India. Dr. Hemanta, are you available online?
Yeah.
Okay.
Yeah, I am
So let
audible.
us welcome our next speaker, Dr. Hemanta Kalita, and he will be speaking on the topic on Dobekrop, Dunford, and Bycroft Dunford integral. So, Dr. Kalita, please.
Okay, my slide are visible.
No. Please share your slide.
Wait. Just how? It's here. A window. Share. Whatever. Now.
No, the slide is not visible. Can you see?
No, it should be visible, what
Yes,
happened
yes, yes.
actually?
Yes, now it's visible. You can just click on the plus so that it will be little bigger.
It's okay.
Yes, visible.
It's
Yes.
not
Yes.
bigger.
Yeah. Now it's fine. Now it's fine. You can present, please.
Okay. Yeah, thank you, Professor. Myself, Dr. Hemanta Kalita, from Department of Mathematics, Assam Don Bosco University. Uh, today in my presentation, I will give a presentation on one of my article on Dobrakov-Danford and Virchow-Danford integral. So, these are the outlines of my presentation: abstract introduction, preliminaries, and Dobrakov-Danford, Maxent-Danford, and Virchow-Danford integral and their properties. Dobrakov-Pettis, Maxent-Pettis, and Virchow-Pettis integral, and few references. So we study integration of Banach space valued function with respect to Banach valued measure. Our main result states the Virchow-Danford integrability implies Maxent-Danford integrability. We also saw that a function is measurable and Maxent-Danford integrable if and only if it is Dobrakov-Danford integrable. So all the integral here are actually generalized integral. So during the period of Banach space, the theory of integration of vector valued function with respect to vector measure was studied. Bartel, Dobrakov method are mostly known. Plenty of quality researchers are involving in this area. More about the Dobrakov theory, including most of the theory, one common failure is that the functions are required to be measurable. Unfortunately, we found uh, in few articles the Birkhoff and Maxent integral do not require strong measurability. Many recent authors caught this attention here, and then Dobrakov-Birkhoff integral are defined as the limit of sum of the formed is where AR is the countable family of pair-wise disjoint measurable sets. So it is a natural to try to extend this integral to the more general setting of vector valued measure. And our purpose here to study such generalization, which are obtained as follows. We will consider a vector valued measure mu with values in a Banach space L, Z, Y, all bounded linear operators from Z into the Banach space Y. We replace this sum, the inner product of by the scalars R times Z to Z with a natural bilinear map LZY times Z tends to Y. Yeah, this is not required. We are recalling few definition. A function J from omega naught, where omega naught is a subset of R to the power n to Y is an scalar integral measurability if inner product of Y star J is measurable for each Y star in the capital Y star. A function J from omega naught to Z is strongly measurable or Bosner measurable if only if J is a pointwise limit almost everywhere of a sequence of measurable simple function. In general, scalar measurable and strong measurability are not equivalent except for the particular case of Banach spaces. Uh, Throughout the article, we assume strong measurability is equivalent to the scalar measurability, that is our measurable function are almost separable valued. So coming to the definitions, if function j from omega naught to j is measurable if there exists a sequence of simple function converging pointwise to j. A function j from omega naught to z is Dobrakov integrable with respect to mu if it is a measurable and there is a sequence of simple function, a simple z valued function Jn converges to J mu cap almost everywhere, where mu cap is here semi variation of U. now a function z from omega naught to z is said to be a star integrable with respect to mu, with a star integration over omega naught z mu d mu belongs in z if for every epsilon greater than 0 there exists a naught belongs in p omega naught such that a equal to this and under norm summation n from 1 to infinity j omega mu n minus a star over integration omega naught j mu less than equal to epsilon with uniqueness of this hold. Now we are coming to our main definition. We are defining the Dobrakov-Dunford, Maxent-Dunford, and Birkhoff-Dunford as follows. A function j from omega naught to x is called Dobrakov-Dunford on omega naught if for each y star in z star, the function y star j is an Dobrakov integrable on omega naught, and if for every subset E of omega naught there exists a vector y double star on E belongs in Z double star such that this condition hold, and we write this as an dd integration over E f. Similarly, we define Maxent-Dunford integral on omega naught if for each x star in z star, the function x star f is an Maxent integrable on omega naught, and we denote it md over integration Ez. So function z from omega naught to z is Birkhoff-Dunford with respect to mu if under norm summation n equal to 1 to infinity j omega mu n minus s star integration omega naught x star z d mu less than equal to epsilon. So now coming to the few core related result above these three integral, we found that if a function j omega naught to j is Dobrakov-Dunford, and then it is if and only if x star j is a Dobrakov integral, and if a function j is Dobrakov-Dunford, then each perfect set in omega naught contain a portion on which j is Dunford integral. And then we found a function j omega naught to j is Dobrakov-Dunford, then there exists a sequence of jk of closed set such that union from k equal to 1 to infinity jk equal to omega naught, then j is Dunford integrable on each jk. We found that Maxent-Dunford integrable if and only if j is Danjoy-Dunford integrable. A function j is Maxent-Dunford if and only if x star j is a Maxent integrable on omega naught, where small x star belongs in capital Z x star. We have seen that a function j from omega naught to z is Maxent-Dunford on omega naught, then there is a sequence of closed set summation union k from 1 to infinity jk equal to omega naught, then j is Dunford integrable on each capital Jk. Also, the function f is Maxent-Dunford integrable on omega naught, then there exists a sequence zk of closed subset such that zk subset zk plus 1 for all k, and union k equal to 1 to infinity jk equal to omega naught, then j is a Dunford integrable on each jk, and this conversion, this limit when limit k tends to infinity d, this one here I make a typo here, it should be then jk, so md, this one uniformly, weakly uniformly on omega naught. We found that if j is Birkhoff-Dunford integrable, if and only if x star j is Birkhoff integrable. If a function is Birkhoff-Dunford, then each perfect set in omega naught contain a portion on which j is Dunford integrable. So similarly, we found Dobrakov-Pettis. Similarly, we define a definition of Dobrakov-Pettis. A function j omega naught to z is called Dobrakov-Pettis if j is Dobrakov-Danforth, and this we write it as this symbol. A function j omega naught to z is called Maxent-Pettis integral if j is Maxent-Danforth on omega naught and there is a vector x double star in j on every subset of E. We write this one. A function j omega naught to j is called x s star Pettis if j is s star Danforth on omega naught and there's a vector x star x double star in z for every subset of E in omega naught, and we write this under this symbol. So with this, from this three definition, we try to find their relation when we suppose that contain no copy of C naught, and then J from omega naught to J is in Dobrakov-Pettis, then each perfect set in omega naught contain a portion on which J is in Pettis integrable. And then suppose Z contain no copy of C naught and J from omega naught to Z is Maxent-Pettis integrable, then each perfect set in omega naught contain a portion on which J is in Pettis integrable. Suppose Z contain no copy of C naught and J from omega naught to Z is an Birkhoff-Pettis integral on omega naught, then each perfect set in omega naught contain a portion on which J is Pettis integrable. So then under the condition Z contain no copy C naught and J from omega naught to Z is immeasurable, if the function J is Dobrakov-Pettis integrable on omega naught, then there is a sequence Jk of closed set with Jk tends to Jk increasing by Jk increases in omega naught such that for each x star in z star, J is in Pettis integrable on Jk, and we found that the Pettis integral converges to the Danforth-Pettis, which is weakly. Suppose Z contain no copy of C naught and J is measurable. If a function J is Maxent-Pettis, then there exists a sequence Jk of a closed set with Jk this is increasing on omega naught such that for each x star in capital J star, J is in Pettis integrable on each Jk, and F converges to Maxent-Pettis of J weakly. Similarly, if Z contain no copy of C naught, J is unmeasurable. If Birkhoff-Pettis integral converges to Birkhoff-Pettis integral converges to Pettis integral, which is converges weakly. So now we discuss about equivalent condition of Dobrakov-Danforth and Dobrakov-Pettis integral. We have found that when Z is weakly sequentially complete, then a function f from E to Z is Dobrakov-Pettis integrable only if for each closed set E naught subset of E, there exists a portion P E naught union E of E on which J is in Pettis integrable. And under the condition Z is weakly sequentially complete, then a function J from E to Z is Maxent-Pettis integrable only if for each closed set E naught subset of E, there exists a portion P of E on which J is in Pettis integrable. So these are few references. Thank you very much for your attention. Actually, in this work, hello.
Yes, sir. You can continue. Yeah.
Yeah,
Okay.
in this work, we tried to find the relation between Dobrakov-Danforth and Dobrakov-Pettis, and both are generalized integral of Danforth and Pettis. Now, coming to the Danforth and Pettis, Danforth and Pettis are
The slide is not visible. Okay. I think there's some issue, technical issue with Dr. Hemant. Let's wait few seconds. Hmm. Oh, Dr. Hemant, you have some issues with the slide. Okay. Hello. You are not audible.
Hello.
Yes, yes.
Yeah,
So you,
yeah. Yes, I'm so sorry. Actually, I was hearing you, but I don't know you are hearing me or not. Yeah, I
no,
was
no,
talking
no.
about that in my article. We tried to find relation between Danforth, Dobrakov Danforth, and Birkhoff
Hemanta, could
Danforth.
you please share your slide? Your slide is not visible.
That's a problem, sir. I am facing. Actually, I am trying, but not getting.
Okay, okay, it's okay. I think you have completed your presentation. So it's
Yes.
okay. Thank you very much, sir, for your talk. Okay. So audience side, is there any question? So if there is no question from the audience side, let us thank the speaker again. Thank you very much for this nice talk. I hope that it will be very useful and helpful for other researchers working in this area. So now we call our next speaker, and our next speaker is Dr. Partha Sarathi Ghosh. Dr. Ghosh, are you available online?
Yes, I am here.
Okay, so let us welcome our next speaker, Dr. Partho Sarathi Ghosh, and he will be speaking on the topic free product of weekly Hegel groups are weekly Hegel group. So, Dr. Ghosh, please present your work.
Okay, so is my screen visible?
Yes, it's your screen is visible. Yes.
Yeah, okay. So, first of all, very much thanks to the organizers for giving me this opportunity. My name is Partho Sharthi Ghosh, research scholar from the Department of Mathematics, Presidency University. As the title suggests, the topic of this today's presentation is free product of weekly Hagerup groups are weekly Hagerup. So, first of all, how this weak Hagerup property came to be. So, this is a generalization of amenable groups. So, what are amenable groups? So, a group is called amenable if there is a G invariant state on the group. And some examples of a group which are amenable can be as any finite group, any abelian groups. And the first non-example of first non-example of amenable group was found by Hagerup, and it is this free group which is not which is basically not amenable, and you can show that if you assume that on the free group there is a state which is G invariant, then you will get a contradiction. So another definition of this amenability can be given by this property that on the group we have a sequence of finitely supported positive definite maps which converges to 1.1. So by a positive definite map, what I mean to say is that if you choose any natural number k from if you choose any natural number k and you for that k, if you choose any k element from the group and consider this type of matrix k by k matrix, then this matrix will be a positive definite matrix. There is a notion of conditionally negative definite functions on the group also, and the definition is like previous way. If you consider any natural number k and form this type of matrix, and the matrix is if that matrix is always conditionally negative definite, then we say that the function on the group is conditionally negative definite. So we have seen that the free group is not amenable, but Hagerup proved that on the free group there is a there is a sequence of there we can there is a sequence of for positive definite yeah, there is a sequence of positive definite functions on the free group which converges to one. But the problem is the functions will not be finitely supported. The functions will be some kind of this vanishing at infinity. By vanishing at infinity, I mean that if you consider the length of the group, length of the element of the group to go to infinity, the value of the function will go to 0. Yeah, and this is basically the definition of Hagerup property for a group. So a group will be said to have Hagerup property if it has on it we can construct a sequence of functions which satisfies these three properties. So now we have to define what is a weakly Hagerup property. So for defining weakly Hagerup property, we need to generalize this notion of positive definiteness to the notion of completely bounded maps. So a function on a group is called completely bounded if the following happens. So given any function phi on the group, we can define its Harshur multiplier from the bounded linear transformations on L to G to bounded linear transformations on L to G via the following ways. And this operator will give us a sequence of operators for every natural number k. And the sequence of operators that is denoted by m phi k, they are basically operators on k cross k matrices, the set of all k cross k matrices whose entries come from BL to G. Yeah, and it is defined in the following manner. So we will say that the function phi will be completely bounded if this sequence of operators m phi k, the norms of these operators are uniformly bounded by some number. Then we say that this phi is completely bounded. So before going to the main discussion, I just want to mention a equivalent condition for a map to be completely bounded is that if there exists a Hilbert space on which we have two bounded maps from the group to that Hilbert space, such that this property happens, that the kernel function of the kernel function for this map phi is basically looks like an inner product. Then we say that the map phi is a completely bounded map. So the definition of definition for a group to have weak Hagerup property is to have a sequence of maps phi n from the group to C, which vanishes at infinity, pointwise converges to 1, and they are the sequence of maps are completely bounded. Yeah, and the completely bounded norm, the this phi n cv is strict is less or equals to some uniform number. Yeah, so the main result is basically if you have two groups, one is G1, another is G2, with this weak Hagerup constant 1, then their free product will also be weak Hagerup. So what do I mean by this free product? This by free product of two groups, I mean to say that it is also a group whose elements will be of one of these four forms, and the group operation is basically concatenating two elements, like what we have what we mean to say by concatenation, that we put one element first, then just write the second element after that, and we just perform the cancellation operation. That is, if there is any inverse of one another, they are side by side, then we just cancel them. Yeah, so how to prove this theorem? So our idea is to basically construct on the component groups, we have two sequences of maps satisfying those three properties. So on the main group, we also have to have a sequence of map with those properties. So our idea is to construct via this. So if we take any element from the free product, like this G1 H1 G2 H2 and Gn Hn, then we can define a function on the free product like this. So here we just saying that just on the component elements we just evaluate f1, since h1 the h comes from g2, we just evaluate h1s on we just evaluate f2s on the h, and we evaluate f1s on g's. Main question is that does this capital F function is completely bounded or not? Because you can see that this function will converges to 1 because the component functions will converges to 1. So Is it completely bounded or not? This is the main question. So for proving that thing, we have to consider a new Hilbert space. We basically will prove this via the equivalent criteria I just mentioned earlier. So we just for the two maps, that is this f1 and f2, we have two Hilbert spaces, and one is h1 and h2, and there are two maps according to for f1 we have suppose alpha 1 beta 1, and for f2 we also have alpha 2 beta 2, and for that we we will just construct a new Hilbert space which is like this h1 direction c2 direction c2, and we will consider two maps defined in the following way. So whatever we get is this kind of function, this kind of function theta I, which is on the g1 to h1 Hilbert space will define like this, and from g2 to h2 just replace I by 2. Yeah. So now we have to show that the map F is completely bounded. So for that purpose, we are now considering this. We just now we need to construct a new Hilbert space. The new Hilbert space will be constructed in the following way. For the free product of these two group G1 and G2, we will consider its Basset tree. That is a tree mentioned by denoted by here this T, and we will perform the tensor product. This tensor over any element small t belongs to capital T over ht tilde, where if small t is a quotient of g1, then we will take ht tilde to be h1 tilde, and if t is a quotient of g2 tilde, then we will take h2 tilde, and we will sorry, and we see that if in this way we construct a Hilbert space H, then the map we defined earlier will be will be a positive definite type. Yeah, but the problem here will be that F will not be the group invariant function. So for that purpose, we need this lemma that if we have two functions on the component groups whose CB norms are less than 1, then we can construct a group invariant kernel for phi n such that this phi n converges to the kernel of F in the CB norm. Yeah, and the proof is quite much done because of this lemma. So we just need to apply this lemma in this case. So just construct a sequence of kernels this eta n from the free product cross free product to C, like this map. And as we can see that yeah, there was a well-defined notion of well-defined theorem by Schoenberg, which says that this exponential of minus this distance function divided by n is a positive definite function on the group, and from the last lemma the second component phi follows that it is completely bounded, hence the eta n's are completely bounded maps. And so on the group we can define it by fn hat like this, and it is a easy calculation to show that fn hat will satisfy those three properties we need to check. Yeah, and so the group gamma, that is g1 free product g2, is weakly Hageru. These are the references, and I acknowledge my department, CSIR and DSTFIST. Thank you.
Thank you very much for this nice talk, Mr. Ghosh. So, is there any question from the audience side? Okay. If there is no other question from the audience side, let us thank the speaker again. Now we call our next speaker, and the next speaker is Dr. Sandeep Kumar Mandal. Dr. Mandal, are you available?
Yes, sir.
Okay, so let us welcome our next speaker, Dr. Sandeep Kumar Mandal, and he will be speaking on the topic increase the number of weak keys in reduced AEGIS. So please present your work.
Yeah. Hello, sir. Is my slide visible and am I audible?
Yes. You can present, please.
Yeah. So myself, Sandeep Kumar Mondal, a senior research fellow in the Department of Pure Mathematics, University of Calcutta. Today my topic is increase the number of weak keys in AGIS. So the table of content of my topic is introduction, distinguishing game, cube attack, weak keys, AGIS 128, and a result in the paper 2 by Fukan Liu, and our improvement over their result, and then conclude the paper. So suppose Alice want to send a message to Bob in an insecure channel. If he sent the message, then some attacker say if can get her message from the insecure channel. So Alice don't want to publish his message. So Alice encrypt the message and send the ciphertext to Bob. So now if can get the encrypted message from insecure channel. Now for encrypting message, there are some encryption function. So the mostly used encryption function are stream ciphers and block ciphers. So if can decrypt the encrypted cipher, then the encryption function is not good. So a encrypted function should immune to all such attack. So now here we discuss some attack on encrypted function. So encryption function are should like random. So next is distinguish game. So let we have two oracle. One is the encrypted function and one is random function. So adversary try to distinguish the encrypted function from a random function. So adversary give a message to the challenger, and challengers choose a random number from 0 1. After choosing random number from 0 1, then the B is fixed. So after fixing B, if B is 0, then challenger choose oracle O0, that is the encryption function, and if B is 1, then challengers choose a random oracle and give the output any number, any random number. So after choosing B, challenger encrypt the message with the oracle and give the ciphertext to the adversary. Now adversary has his own algorithm, and after analysis all the yi, he conclude that b dash is the b. So he guess b as a b dash. So adversary win if b dash equal to b. Now how many times adversary will query? Now adversary can query less than exhaustive search. If adversary can correctly guess B with a query less than exhaustive search, then adversary will win. So the success probability of this attack is guessing the correct B. If the success probability is greater than half, then the adversary will win. So this is the distinguished game. So if adversary win, then the cipher is, we call the cipher is break. So here we say that adversary has his own algorithm. So now we discuss one of them algorithm. So the algorithm is cube attack. Let a cipher has, so a cipher has two input. One is secret key K and the initialization factor, which is known to the attacker and all, but secret key is unknown to all. Now let f be the encryption function. So f is a function of key and IV. For simplicity, here we say that the output is a one bit. So for example, let for a given key IV, the output of the function f by output of the encryption function is 1 plus k2 v1 and this. So what is cube attack? First, since IV is known to the all, so first adversary try to different IV and get the output. So adversary take as a v1, v2, v3 his variable and run the output over all possible V1, V2, V3 and sum the outputs. So, so what is the output? Actually, we run over the V1, V2, V3. So where V1, V2, V3 present, there is only one option, they all are 1. And for other option, there is should 1, 0. So this sum will be 1. And for other sum where one of these V1, V2 is not present, then suppose in this function V3 is not present. So when V3 equal to 0, V3 equal to 0, then here some in value come, and when V3 equal to 1, then same value are also come. So we get the same value even number of time. So after joining this, we will get the 0. So the actual sum of these is, for this the sum is 0, for this the sum is 0, and for this the sum is 1, and for this the sum is 0. Since here V3 not present, here V3 not present, here no one variable present, but here 3 of all variable present, so the sum is 1. So actually we see that this is nothing but the coefficient of V1, V2, V3. So if here, like in this function, if here K1 is present, so then the sum will be K1. So this is the cube attack. So here we if we sum over this cube variable, then we always get 1. But for a random function, if there is a random function, then the sum sometimes we have 1, sometimes we have 0. So we can distinguish f from a random function. So this is the idea of adversary, for distinguish the encryption function f from a random oracle. So now what is the weak keys? So if a cipher is breakable for some types of key, like if the key satisfy some condition, then the cipher is distinguishable from a random oracle. Then that key are said to be weak keys. So for example, let the fkiv function is this. So if we get the sum over v1, v2, v3, then we get the coefficient of this v1, v2, v3. So we get k2 v5 plus k3 v4. Now if k2 equal to 0 and k3 equal to 0, then this sum will be 0. So if the attacker use the key k where k2 equal to 0 and k3 equal to 0, then this sum is 0. So attacker should not use those key for which the k2 equal to 0 and k3 equal to 0. So if attacker use a key where k2 equal to 0 and k3 equal to 0, then some adversary can break the cipher but can distinguish from random oracle. So now our attack is on the cipher AGIS 128. So some basic of AGIS 128. AGIS 128 is a stream cipher and its inputs are key, IV and associated data. So AGIS 128 gives some key stream and it has 10 initialization rounds. So our attack is on initialization round and on reduce AGIS. So we can attack AGIS up to 5 initialization round. So that's why we attack AGIS in reduce round. So in AGIS 128, an element which is 128 bits element can be represented at a matrix form, and the first entry is 00 and so on. So each entry is 8 bit, so total 128 bits. So these are the notation which are used in a paper by Fukan Lu, and we improve that attack. So we use their notation also. So subbytes is the AES, subbytes shift from X column at round key. This is the operation of AES, and AX means mixed column shift to subbyte, RX means at round constant mixed column shift to subbyte. So here is the actual attack is on the diagonal. So this is the main diagonal and we call this is the other diagonal. So here are 4 diagonals. So in their attack, they give some proposition but result on AES. This is the proposition which is not discussed due to time. So these are result, and using this result, they shown that if we run the cube variable over main diagonal, then the output of the ag is 120 is sum is 0. That is, if we choose the cube variable over the diagonal, the output sum is 0. So when this is happen, when the key satisfy this condition, so key satisfy keys or C1, so applying A, the diagonal of this is equal to the diagonal of the original key. So if key satisfy this condition, then this happen. So if one use these types of key which satisfy this condition, then the cipher will be attacked. So there are actually diagonal content 32 bits. So there are 32 equations. So actually there are 2 to the power 128 keys. So 32 reduced by 32. So there are 2 to the power 96 weak keys for which they attacked. Now our improvement is we show that for all diagonal the output is 0, and here the condition is over diagonal. That is, if we variable cube variable over this and the key satisfy also the condition over this diagonal, then the cube sum is 0. Again, if we choose cube variable along this diagonal, then also the cube sum is 0. So we get 4 cube variable for which the cube sum is 0. So we attack this cipher. We increase the number of weak keys from 2 to the power 96 to 4 into 2 to the power 96. That is 4 times of 2 to the power 96 to 2 to the power 98. And the complexity of this attack is, since the cube variable size is 32, so the complexity of this attack is 4 into 2 to the power 32 equal to 2 to the power 34. So this is the references of our paper, and thank you.
Thank you very much for this nice talk. So is there any question from the audience side? So if there is no other question from the audience side, just I have one query. Okay, so first one suggestion I have. So you are using some references, right, in your presentation. Can you share your slide?
Yeah.
Oh, you did already. Okay, I think he left.
Yeah. Oh, sorry.
Oh, you.
Yeah, I just wait, sir.
Okay, can you share your slide? Yeah.
Yeah.
Okay, so you used. Okay, you are using. You are working in cryptography.
Yeah.
Okay. Okay, you are see. I have one suggestion for you. So you are using like this. You see results in 2 by Fukang Lu, right? So some places in the slides you are writing like that, means showing some references. So my suggestion is this. Yes, this. So instead of writing 2, 3 something, is better to give the full reference in a smaller way or teeny way at the bottom.
Okay.
So that people can see. You understand? Because when you are presenting, we are unable to understand what is the meaning of 2. You understand my point? So this is a small suggestion from my side.
Thank you, sir.
Okay. Thank you. And the talk was interesting. Okay. So thanks a lot. Hope that your talk will be useful for other researchers also. Okay. Let us call our next speaker, Dr. Himadri Sekhar Roy. Dr. Roy, are you available?
Yeah, am I audible, sir?
Yes. Thank you. So let us welcome our next speaker, Dr. Himadri Sekhar Roy, and he will be speaking on the topic TMTO attack on a particular block cipher. So, Dr. Roy, please present your work.
Yeah. Is my screen visible?
Yes, it's visible.
Okay. Thank you, Saurabh sir, for introducing me. And thank you, Professor Abhishek Adhikari sir, Founder Secretary MBIC, for giving me an opportunity to deliver a talk. and good evening to all according to Indian Standard Time. And also thanks to my previous speaker, Sandeep, who delivered a talk on basic cryptanalytic techniques. Now I will continue with one of them. And I am Himadri Shekhar Roy, a scholar from Presidency University, and the title of my topic is Time Memory Trade-off Attack on a Particular Block Cipher. So first of all, I will discuss about the content of the attack, and first I will discuss about the background and history, then I will discuss about the concept, and then I will discuss about the two different methods of the attacks. So in the background and history, I will first discuss about the exhaustive search. And according to exhaustive search, if an attacker has a plain text and ciphertext, and he or she will find the key from key space, and he can apply exhaustive search in two different ways. The first technique is he just encrypt the plain text using different keys, and he will get different ciphertext, and he store the ciphertext and corresponding the keys. And in the other online phase, he will check that the ciphertext is equal to the original ciphertext or not. If equal to the original ciphertext, then corresponding key is the master key. So using these techniques, the total memory will be order of capital N, and total runtime will be order of log n base 2. And in the other techniques, he or she will encrypt the plain text using the key, and he will get the ciphertext and check the ciphertext is equal to original ciphertext or not. And using this technique, the total runtime will be order of n, and total memory will be order of 1. But time memory trade-off attack, actually the trade-off between the memory of the technique 1 and the runtime of technique 2, and it first introduced by Martin E. Hellman 1980 to find out the inverse of one-way functions. So first of all, what is the one-way function? So one-way function is a function where easy to get the images, but very difficult to find out the pre-images of image. And here also how to make a function called f functions during the attack, which is a very important function. And the main property of that function is a function from key space to key space. So how to make that functions? Actually, we just fix the plain text equal, then we apply a function r, which maybe reduce some bits of ciphertext or adding some constant bit of ciphertext to adjust the bit of key and ciphertext bit. And according to examples, the DS, for example, DS, the block size is 64 and key size is 56. So here R work as a reduction function, but in Kasumi, R adding some constant bit. So the concept of the attack is a chosen plain text attack, and it is a probabilistic attack. And in the attack, it has two phases. One is a pre-computation phase, and other is the online phase. In the pre-computation or offline phase, the total runtime of pre-computation phase is order of capital N, and if the attacker is done pre-computation phase once, then he or she will apply the online phase repeated time to recover the secret session key for different times. And after that, I will discuss about the two different methods. One is the Hellman methods, and other is the rainbow methods. So this is the Hellman tables. In Hellman tables, we use in a single Hellman table, we use the same functions, and in the different Hellman table, we use the different Hellman table and different f functions. And how to create the Hellman tables? First, we choose m distinct start point, and we apply the function called f functions. We apply it iteratively up to t times, and we will get the endpoints. And we store a start point, we store endpoint and corresponding start point, and after that we apply the online search algorithm, and we will get the we will get the secret key, and this is the algorithm of pre-computation phase and the online phase. And what actually done in the pre-computation phase here, actually the start point is a point from a key space, and the attacker choose a point from key space and then encrypt the chosen plain text using that key and get the output, that means the ciphertext, and apply the R functions, and he will get a point from key space. So repeatedly he apply the functions, f functions, and which is actually the combination of two function, encryption and R functions, and we'll get the endpoint, and shorting the endpoint and store the start point and endpoint. And in the online phase, he has a ciphertext, and he apply first reduction function uh, and check that the output is any endpoint or not. If not, then he will apply the f function and again check that it is endpoint or not. And if he will get an endpoint, then he create the chain from the start point to recover the secret key, and in that case the false alarm may rise. So in the rainbow table, for the different column, we will apply the different functions, and first the attacker choose the start point, distinct start point, and apply the different functions. For example, for say t times, apply the t different functions and get the output, and it's called the endpoint. And similarly, the sorting the endpoint and store endpoint and corresponding start point. And during the rainbow table, the total memory size will be order of m and t, and total runtime of the online phase will be t square by 2. And this is the analysis of the single rainbow table. In a single rainbow table, we choose two parameter m and t such that mt square is equal to n, and where total element of one rainbow table is mt square, and total memory will be mt, order of mt, and runtime will be order of t square by 2. And trade-off curve is m square t is equal to n square, and the important things is that the runtime of a rainbow table is half of the runtime of a Hillman tables. And in case of success probability, here the relation between the success probability and metric stopping constant, and using this relation we can create the attack on a particular cipher. And here is the false alarm. False alarm actually the attacker get a matching endpoint, but it does not necessarily imply that the key is in the table, because the key may be the part of the chain which has a same endpoint, but is not in the table. So then false alarm raised, and the Hillman proved that the expected number of false alarm for a table of element m cross t can be bounded by the mt into t plus 1 by 2n. So now I will discuss about a block cipher which is called dot. And first I will discuss about the history, then I will discuss about the introductions, algorithms, and after that I will show the experimental result and attack implementation, and at the end I will show the outputs of my attacks. Here the block ciphers. Actually, the block cipher basically the encrypt n-bit plain text to n-bit ciphertext using key, and key bit may be different from the plain text bit or ciphertext bit. So these are the common size of block size. These are the common examples of block size and the most common examples of key size. And the most common structures of block cipher is SPN based, crystal based, and ARX based. And in a block cipher, the same function called round function apply iteratively, and we can get the outputs. So dot is a SPN based block cipher. Here input and output size is 64-bit, but key size is 128-bit or 80 bits, and here the number of round is 32. And in 2009, Patil et al. Developed the block cipher, and it is used same as box as present cipher and Lisi cipher. And these two are the algorithms of the cipher left hand side of my slide is the encryption algorithm. In the right hand side of my slide is the key scheduling algorithms of that cipher. And and the slide represents the experimental results, and in the left hand side the results for the success probability 0.73 for full key version of dot cipher, where we take the key bit as a 80 bit. And in the right hand side represent the practical attack on weak key version of dot cipher. And in the top of the right hand column represents the results for success probability 0.73 for weak key version of dot cipher, and in the bottom table represents the result for the success probability 0.80 for weak key versions of dot cipher. And here weak key versions, actually we take 32 bit as unknown and we concatenate it up to 128 bit. And this is the experimental results. Also in the pre-computation phase for the success probability 0.73, we choose the fixed plain text, which actually given in my slide, and the average time will be 932 minutes, and for success probability 0.80, the average time will be 1332 minutes, and in the online phase, uh, the the secret key is recovered in less than 1 minute. So in the practical attack implementations, we implement the time memory trade-off attack on a dot block cipher, and we assume 32-bit key as unknown and concatenate it up to 128-bit key, and we will successfully we successfully mounted the attack on dot block cipher, and we recovered the key with very high probability. And these are the output of my personal PC, where we introduce the attack for the ciphers, and the left hand sides are shows the offline time for the success probability 0.80, and the right hand side shows the key recovering part. And these are my references, and thank you. Is there any question?
Thank you very much for this talk. Is there any question from the audience side?
I have one. Can I ask you?
Yes, yes, yes,
Yeah.
definitely.
So can you go back to that one-way function, means that slide?
Okay. Yeah, this one.
Okay, got it. Yes, yes. So you stated that means it's easy to get an image, but it's very hard to find out its inverse. So
Yeah.
what makes this assumption that f of ki is equal to r of means and cipher of p naught? How does it make sure that it's not a means it's hard to get an inverse of it?
Okay. So actually, first of all, I actually define that what is the one-way function, and easy to get image. That means there exists actually one-way function is a function from 0 1 star to 0 1 star, right?
Yes.
And easy to compute image. That means there exists a deterministic polynomial time algorithm, say A, such that on input on that algorithm, and it gives an output in a polynomial times. And hard to get inverse, that means for every probabilistic polynomial time algorithm and every probabilistic and every positive polynomial, say P, and also large N, the success probability is very negligible. So in that case, we create the function f as like of one way. So we actually apply the rainbow methods, and using rainbow methods, we actually find out inverse of any functions using that methods. But in the Hellman methods, particularly, it will apply on actually one-way function. So not necessary that f may be a one way or not.
Okay.
Do you understand?
Thanks. Thanks. I understood.
Thank you very much for this talk and this nice interaction. Okay, uh, hope that this talk will be useful for other researchers also. So let us
Thank
welcome our next speaker, and our next speaker is Dr. Shubham Mukherjee. Are you there online?
Yes, sir. Am I audible?
Uh, Hello? Yes, you are
Hello.
audible. Let us welcome our next speaker, Dr. Shubham Mukherjee, and he will be speaking on the topic chaotic image encryption using Henan map. So please present your work. And we have
Yes.
limited time, so try to finish within 12 minutes, including question hour session. Question and answer. Dr. Shubham, please share your slides.
Shubham, we cannot hear you.
Sir, am I audible?
Yeah, now it's audible and
Now it's
So, good evening, everyone. First of all, I would like to thank the organizer, Abhishek sir, and a special thanks to give me a special chance on the next day. Basically, I am trying to say some elementary idea on chaos-based image encryption. There are a lot of existing literatures on chaos-based image encryption, but still we are trying to do something new since we are working. So I am trying to give some elementary ideas. First of all, I would like to mention what is chaos. Basically, chaos measures the unpredictability of deterministic nonlinear dynamical system. Around 1963, famous person from MIT, Edward Lorenz, first remarked this natural phenomenon. So what is chaos? Basically, a small change in initial condition produces rapid divergence for a chaotic system. His conference talk from 1972 become very famous. His talk was predictability. Does the flap of a butterfly wing in Brazil set off a tornado in Texas? So this kind of question generate a interesting issue throughout the world. Hopefully, many person know the issue of butterfly effect. But Lorentz is not the first one who gave this idea. Before that, around 1922, French mathematician Hadamard first introduced system exhibiting sensitive dependence and so on. So this is the first scenario of chaos. And my next thing is cryptography. So already few previous speakers have mentioned interesting facts about different block ciphers and so many things. So I am not going into the detail. So in brief, what is cryptography? This is the study of secrecy and of secure communication in presence of eavesdropping adversaries. So depending on some nature of keys, we can categorize basic techniques, symmetric and asymmetric. So AES, DES, Diffie-Hellman key exchange, RSA, these are few basic examples. So what we will do, and basically what is the basics of this chaos-based image encryption? Similar with the dynamical system, we can identify different issues of cryptographic algorithm. We have set of real numbers, some control parameters, some sensitivity to the initial conditions in case of dynamical system. And similarly, in case of cryptographic algorithms, we have a finite set of integers, we have some secret keys, and the issues of confusion diffusion. So in case of dynamical system, we can observe nonlinear structural complexity, and in case of cryptographic algorithm, we can identify algorithmic complexity. So basically, we will focus on two things: confusion and diffusion. So first of all, I would mention the basics of Henon map. What is Henon map? Michel Henon proposed the simplified version of the Lorentz attractor. The map is defined as follows: we will get some recursive relation xn plus 1 equals to 1 minus axn square plus yn, and yn plus 1 equals to something. So in this case, a and b are the basic two control parameters. So using these two control parameters, the sequence either diverges or converges to a strange attractor. So in this case, using a equals to 1.4 and b equals to 0.3, we have generated this kind of figure. This is the issue of Henon map. And secondly, we have used logistic map. Renowned biologist Robert May proposed this one-dimensional map around 1976. So the map is again a recursive relation. Ln plus 1 equals to alpha ln into 1 minus ln, where ln can assume the values between 0 and 1, and alpha is considered as the control parameter, whose restriction has been mentioned to take the value from 1 to 4. This model depicts the complex chaos originated from very simple dynamical system. Generally, the values of alpha as 3.8 shows the chaotic nature. So what we have done, basically, we have composed these two maps, Henon and logistic maps. Around 1976, again, we have got a series of works by Pomu. In this case, we have chosen a specific form of Henon map. Xn equals to alpha minus beta xn square plus gamma xn minus 2, where alpha, beta and gamma have been mentioned, and we have given the time series plot of this coupled logistic map. So in this regard, we should mention few existing literature. Around 1990, we have got the basic ideas of chaos-based cryptography due to some researchers. After that, around 2001, Il Korasev published a paper on the title Chaos-Based Cryptography, a brief overview on IEEE magazine. So according to his famous work, chaotic cryptography seems more powerful than the classical encryption technique. After that, we have got few other things. Guan and some others used Arnold CatMap for spatial domain in encryption method. Applying chain system to output signal, the encryption was performed. The result describes the necessity of large key space to resist any differential attacks. Again, as per works of Gao and others, 1D chaotic map for image encryption is not secure at all. That's why the author incorporated the notion of hyper-chaotic system. Initially, pixel shuffling was performed by a logistic map. Further, hyper-chaotic systems were employed to convert gray pixels. Huang and others proposed new pixel shuffling process with multi-chaotic system. In that work, FIPS tests have been performed, and they have computed NPCR, USCI and other few things using 4 chaotic systems. So these are few remarkable existing literatures in this regard. And next, in our case, what is the encryption scheme? First of all, a nested bitwise XOR operation was performed over the output sequence of the previously mentioned coupled map to generate our key space. So first of all, 4 keys of the form ki were extracted. But our next target is about stream generation. So this is the algorithm to produce 256 bits scrambled array. And performing this previous algorithm several times, an array had been formed using the sequential shaped values. So the concatenation of the aforesaid array with the first key, that is K1 16 cross 16, and repetition of that previous algorithm provided us the new 4096 bits keys, which is denoted by KI 64 cross 64, where I varies from 1 to 4. And what is confusion? Basically, we need to split the image into several blocks. So we have mentioned the blocks by BI, and arranging the pixels in each block, we had constructed the array of scrambled block with shape of 256 cross 256. So this is our scrambling process. And next, for descrambling, the previously used scrambled image had been splitted into different blocks of the form SCI. The scrambled image was arranged according to the index sequence of chaotic output. The generated array gave the descrambled image. After confusion, we have to use the techniques of diffusion. So what is diffusion? The scrambled image C cross C had been arranged into different blocks, which is denoted by SCI. In this case, I varies from 1 to 16 in terms of different pixels. But next point is vital. Bitwise XOR operation was performed between SC1, K1 and D1. We know that SC is previously mentioned block. K1 is our first key. But what is D1? I will mention that in the next slide. So what is D1? So bitwise XOR operation between these three terms produce the block cipher C1 64 cross 64. So in similar fashion, we can generate the remaining block ciphers. But what is D? So now the issue of initial block generation comes. Firstly, in our coupled Henon logistic map, there are five parameters. So 5 parameters of the coupled system were placed in an array, say M. Next, the values of Mi were placed in Zi, where I varies from 1 to 5. And finally, we have to use this recursive relation to generate the block dk equals to bit of XOR operating on dk minus 5, dk minus 4. So this is a recursive relation. And the size of the array was basically 4096. So this
Sorry
is
for the
the...
interruption. Hello, sorry for the interruption. Please bind up because we have limited time.
Sorry?
I just request you to please bind up because we have limited time. We have to complete within
Okay,
12
sir.
minutes.
Sure. So this is the scenario of basic encryption. And in case of decryption, how can the receiver decrypt the original? In that case, we have to use inverse diffusion and inverse confusion to get the original image. So what is the output? In this case, on the left side, we have a few basic image and we have got the encrypted image using confusion and diffusion for several rounds. And after that, these are the decrypted image. And I have to mention this Lyapunov exponent. This is the measure of average exponential rate of expansion. Positive values of Lyapunov exponent implies the chaotic nature of dynamical system. So in this case, using some Jacobian matrix for a dynamical system, we have got this kind of figure. And we have performed the basic NIST test. This is most common to check the randomness of any chaotic sequence. In every case, our model has passed and p-value have been mentioned. In 11 case, in this case, 100 groups are used. And this is the issue of histogram analysis. What is this? This is the process of graphical representation of pixels. Basically, on the left side, I have some figure, and corresponding to that, we have some histogram analysis. There are some different peaks. But in case of encrypted image, the histogram says the uniformity. That means, that implies the effectivity of our crypto system. And next issue is correlation coefficient. In this case, we are trying to measure the connection between adjacent pixels, which is vital feature for image encryption. In this case, we have to use standard deviation and expectation for different grayscale values of 2 pixels. So the values have been mentioned for original and encrypted image. And the next one is information entropy. This is a vital thing for information theory. So in this case, for 256 gray levels, entropy value should be near equals to 8. But in our case, calculated values are 6.9236 and 7.9997 for cipher image. So that means more or less this is good. And the next thing is differential attack. So USCI, that is Unified Average Changing Intensity, is used to compute intensity difference between original and encrypted image, and we can use this kind of summative formula where Yj represent the ijth pixel of original and Eij represent the encrypted image position of that pixel matrix. In our case, UICA, this intensity value for the first case is 33.4588, and the next and last thing is NPCR, that is number of pixel change range. This is also a vital statistics to estimate efficiency of our encryption scheme. NPCR also can be defined using some summative notion, summation Cij divided by PQ into 100, where Cij represent the change in pixel values and it can assume 1 when Yj and Eij are different. So in our two cases, NPCR values are 99.30 and 99.61, so on and so forth. So these are a few basic references which we have mentioned, and there are so many existing literatures, but still we are trying to do something better. And again, I would like to thank the organizer for giving me such chance.
Thank you very much for this nice talk. Hope that this will be helpful for other researchers working in this direction. Thanks a lot. So now we'll call our next speaker, Dr. Manjeet. Dr. Manjeet, are you available up there?
Yes, sir.
Okay, okay. Please present your work.
Sir, am I audible?
Yes, yes, yes. So let us welcome Dr. Manjeet. He will be speaking on the topic common fixed point theorem in M-Fuzzy matrix space. Dr. Manjeet, please present your work, and we have 2 minutes time into the question answer session, please.
Yes, sir. Yes, sir. Definitely, sir. Thank you very much, Saurabh, sir. Good evening, everyone. Myself, Manjeet. I am research scholar from Department of Mathematics, Mercy Gandhi University, Rohtak, Haryana. I am presenting a research paper on the common fixed point theorem in M-Fuzzy matrix space. In this paper, we have proved a common fixed point result for 6 self-mapping under a weakly compatible condition in M-Fuzzy matrix space. So let's come direct to the introduction. In 1965, the theory of the Fuzzy set was investigated by L. A. Zadai. In last many years, there has been a great development and growth in Fuzzy mathematics. Mustafa and Sim firstly introduced geometric space. Subsequently, many authors have applied various forms general topology of set and developed the concept of the Fuzzy space. We use the concept of the Fuzzy topology and analysis in the theory of Fuzzy set, and its application have been developed by several eminent authors. Now, in 1975, Chromasil and Michael introduced the concept of the Fuzzy matrix, which opened a new way for the further development of the analysis in surface space. Several authors have introduced Fuzzy matrix space in different ways, as George and Viramani modified the concept of the Fuzzy metric space. Then we studied Fuzzy as a short form FM space, Fuzzy metric space, then G Fuzzy metric space as short form GF. In 2006, CPT and Sobel introduced D star metric space as a probable modification of D metric space and studied some topological properties which are not valid in D space. Based on D star metric space, they define M-Fuzzy metric space and prove a common fixed point theorem for true mapping under a condition of weak compatible and R commuting mapping in a complete metric space. In this paper, we prove a common fixed point result for the 6 set mapping on a given set under a weakly compatible condition in MPG matrix space. Now let us define PG set, a subset of a universe set X, which is membership of a subset of a universe set X with the membership function mu x, which may take any value from the interval 0 to 1. Now let us define continuous p-norm, or we can say that it as a PG operator. Binary operation or a binary operator star defined from closed interval 0 1 cross 0 1 to 0 1 is continuous p-norm if it satisfies the following four properties: associativity, commutativity, it's continuous, A star 1 is A for every element of 0 to 1, and A star B less than C star D whenever A less than C, B less than D for every element A, B, C, D belongs to 0 to 1. Now, here we have two examples. A dot B, A star B is product of AB or minimum of AB. These both examples satisfy all the conditions of our continuous T-node. Now, let us define FM space or a geometric space. If X is any set, star is a continuous T-node, and M is a geometric space. M is a metric space defined on the X cross 0 to infinity satisfy these five properties. Mx by 0 is 0, Mx by t is 1 whenever x and y, that is symmetric, x and y are same. And third is x by t is equal to m of y x t. Third is rectangular inequality in our metric space, general metric space. Mx by t star m y z x less than equal to m x z t plus x. Now, fifth condition is modified from our G matrix space. Mx dot defined from closed 0 to infinity to 0 to 1 is left continuous. And these five properties have thought in our mind that these generalize to the nearest distance between x and y with respect to t. Now, MPG matrix space. MPG matrix space, if X is an arbitrary non-empty set, star is a commutative T-node, M is a PG space defined from X Q cross 0 to infinity. Satisfy these five conditions. First is non-negative. Second is symmetric. Second is symmetric. Third is symmetric with permutation. Second, we can also say that it has identity in our matrix space. Fourth is mx by a t star m a z z s less than equal to x y z t plus s. And fifth is mx by z dot defined from open 0 infinity to 0 to 1, which is continuous. Now, I prove a lemma will be used in our result. MPG space x m star df MPG metric space this m x y z and t is non-decreasing with respect to t. For every x y z belongs to x. A proof of this is varied by the fourth property of our previous definition of MPG metric space. We prove this by contradiction. Come to the main result. Let the three tuple x m and star be a complete MPG metric space, and let it we consider six self-mapping owners: alpha, beta, gamma, delta, tau, and mu. And take a pair like this: alpha and delta, beta and tau, gamma and mu as weak compatible. Also, alpha, delta of x contained in beta of x, and tau of x contained in gamma of x, mu of x contained in alpha of x. And also let's assume that alpha of x is complete if there exists a k belongs to 0 to 1, which satisfy this. The four of maximum m of alpha x, beta y, gamma z t, similar with all the three, must be less than equal to m of delta x, tau y, gamma z, and k. If this hold for every x, y, z belongs to x, then there exists a unique and a common fixed point for alpha, beta, gamma, delta, tau, and mu. This form in two methods, in two parts. First, we will prove that all the six self-mapping have a common fixed point. Then we will prove that that fixed point is unique For uniqueness, it is direct. We assume that it has two and show that both are same. So come to the proof. We take our given from our given set X, assume two subsequences, Xm and Y, and take three subsequences, Y3m plus 1, Y3m plus 2, and Y3m plus 3 from the Ym, and take in a such way that Y3m plus 1 is equal to delta X of 3m, beta X of 3m plus 2, and Y3m plus 2 is tau X of 3m plus 1, and gamma X of 3m plus 2. Y3m plus 3 is gamma X of 3m plus 2 and alpha X. Just put all the three equations in our given equation 1, and we get these two statements. Now, by the lemma, we arrive that mx must be known. We arrive here. In a similar way, we get the next equation. Hence, ym is FOC and x is complete. Then there must exist, by the definition of the complete, there must exist a z in x such that ym converts in that z. This implies that every subsequence of ym also convergent. This will imply that limit of beta xm 3m plus 1, delta xm 3m, tau x 3m plus 1, and limit of alpha x 3m and gamma x 3m plus 2. All these have limit z. Now we will claim that the limit of delta z, delta w is z, and we will show that this w is same as our fixed point which works like z. Z behaves like for every all these six mapping as the common fixed point. We just take the subsequences and take limit because we have proved that every subsequence converges to the common fixed point. We just put the m of delta w tau x 3m plus 1 mu 3m plus 2 and kt must be greater than all. We just take the limit and that m tends to infinity and arrives the last condition. Now, as the last condition we have seen, all the equations are same. This will imply m of del w z z kt is 1. This will imply del w is equal to z is equal to alpha w. Hence, w coincide with the delta and alpha. And our first condition is delta of x contained in beta of x. This will imply if z belongs to delta of x, implies z will be scalar multiple. Beta will be scalar multiple of some t. Beta t is z. Now take again in a such a way. Again take subsequences. Then we have at same m tends to infinity. That is m of t, m of z tau t, z and kt is 1. This will imply tau t is z is equal to beta t. Then again we get a t, a coincident point if beta and tau. Again tau of x contained in gamma of x. This will imply z is equal to tau t belongs to gamma x contained in gamma x. So tau x contained in gamma x. This will imply that there exists a v belongs to x such that which is a scalar multiple. If there exists a v which is scalar multiple of gamma, it's equal to z. Now again we take the same for the third one, 3m plus tau x 3m plus 1, and we conclude that gamma v is z, and earlier two equations says that gamma v is equal to alpha v is equal to z. Since all the six alpha and delta, beta and tau, mu and gamma are v compatible, and they come and coincide point. We have delta w is z is equal to alpha w. Then alpha z is equal to delta w.
Sorry for the interruption. Please bind up and conclude.
Since gamma and v are v compatible, similarly gamma z is equal to mu z. Now again for the last one, we conclude that delta w, delta z is equal to z is equal to gamma z, which hold for alpha, beta, gamma, and delta. Hold for every this hold for every self mapping. This will imply that alpha z, gamma z, beta z, tau z, mu z, gamma z for implies Z is a fixed point. This will imply Z is the common fixed point for all the 6 self-mapping. Now we will just prove this. This is the only unique fixed point. We assume that Y is another fixed point by the fourth condition of our given equation first. We will get that M X Y Z K T must be greater than 1. This will imply Y is equal to 10. Hence we can prove that all the 6 self-mapping have a common and a unique fixed point. Fixed point theory has many applications in several branches of the science such as game theory, nonlinear programming, economics, theory of the differential equation, etc. This paper we have proved a common fixed point theorem in empty geometric space. Our result present in this paper generalize and improve some known result in geometric space.
Okay, thank you very much for the interesting talk. Is there any question from the audience side? Is there any question from the audience? Okay, if there is no other question from the audience side, let us thank the speaker again, and thank you very much for this interesting talk. Okay, let us now I hand over this session to Professor Odhikari, organizer of this
Yeah,
conference.
thank you, Saurabh. Thank you, Saurabh, for chairing this session and accepting our invitation to be a session chair. And thanks a lot for organizing this nice session. And all the thanks to all the speakers who have completed their presentations within due time. So it's really a nice session. So thanks you once again to all the speakers as well as the session chair, Dr. Saurabh Das. So with that, let us very quickly move to our next technical session. The last and final technical session of this, that would be 6. And for that, we have a little changes here. Unfortunately, Professor Bhagisha Mukherjee won't be able to give a lecture today because she is ill, but she told that she is trying to do so. If she can, she will join later on. That's why we have Jyotirmoy Pramanik, Dr. Jyotirmoy Pramanik, as a speaker in this session. So this session will consist of 4 speakers. Dr. Jyotirmoy Pramanik, Dr. Shapon Kumar Odhikari, Karl Schupp, and of course, Professor Shuit De. It's too early morning in US. That's why I think, though I am thankful to Karl, because in spite of too early morning in US, he is there with us. But Professor Shuit De will be joining soon, maybe. But before that, it's my great pleasure to hand over this charge of this session to Dr. Parthasarathi Rai, who is currently at Wollongong University, Australia. So without any further ado, it's my great pleasure to invite Dr. Parthasarathi Rai. Partho, the session is yours.
Thank you, sir. So now we are going to start the last technical session of MSAST 2022. So the first speaker, Dr. Jyotirmoy Pramanik, and he will going to present some newer attacks on image secret shading. So this session actually more or less all the speaker will have around 30 minutes time. So around 25 minutes time, I will keep you remind that where we are now. So please, Jyotirmoy, for coming 30 minutes, the stage is yours.
Thank you, Dr. Roy. I hope my screen is visible by now.
Yes, you're perfectly audible and your slides are visible. Please.
Okay. So this work is about some newer attacks on image secret sharing, and this is a joint work with Mohammad Kutubuddin Sardar. So while presenting this talk, I will try to give a sort of motivation to as to why this kind of thing is needed in today's time. So I will begin with a very famous quotation by Clive Humby, which goes by data is the new oil. As we know, world there was a time when the world was run on oil, and now the data is the new oil. And I will take the liberty of going through some more quotations of similar taste, uh, like data is the new soil. So David McCandless is going a bit further and claiming that the it's not data is not only soil, sorry, data is not only oil, it's a new soil, because we practically stand on data, and if there is no soil, if there is no data, and if there is no proper management of data, we won't be able to survive in today's time. So just to give an uh, a perspective, just to put things in perspective of how much data are we talking about. So I've tried to summarize a few famous websites or softwares or apps in front of you, and the amount of data that they process on a regular basis. So for example, Google, the most common search engine, it processes over 5 exabytes of data every day, where if you look at the figure exabyte, it is basically 5,000 of GBs of data. So Google is processing this much of the data every day. uh, you can convert this data in terms of standard desktops. So in other words, Google every day processes data which is processed by 1 crore standard desktops. So just these are just some comparisons uh, to make us understand what kind of, I mean, how big is too big. So I'm trying to quantify that thing through this slide. So we know about Facebook. Facebook generates 4 petabytes of new data every day, and in every minute, Facebook generates 4 million likes. So there are 40 lakh new likes every minute. So you can understand how much of data has to be processed. Similarly, WhatsApp is a very common app or software that we use nowadays, and every second 70 million messages are being sent. So 7 crore messages per second. It's a huge amount of data to be processed in a very short time. So the concern is to privately process data and privately store data. So since we have a huge amount of data to be processed, the most pertinent question is how to keep your data private. And a very natural answer to it is by encryption of data. So what do we mean by encryption of data? So very roughly speaking, suppose we have our data and we put all our data in some storage, say some box, and we lock that data with a choice of our lock, and we preserve that key very safely. So this is a very rough um, way of encryption of data. Now, encrypting data in practice is broadly divided into two type of encryptions. One would be symmetric key encryption, and the other one would be public key encryption. The symmetric key encryption keeps in mind that here the encryption key as well as the decryption key would have to be the same, meaning the key that is used to encrypt your data is also used to decrypt your data from that very encryption. And some popular symmetric key encryption protocols may be listed as the list as I have provided here, like AES, RC4, DES, and all. There are many more examples, but just to get an idea, I've tried to put in list of the most common ones. And to be talking about public key encryption, here we need two different nature of keys. One would be called an encryption key, the another would be called a decryption key. It might be the case that both of these keys are same, but it's not the general case. So in general, you will need two keys or two kind of keys to protect your data while using public key encryption scheme. One would be an encryption key with which you will be encrypting your data, and the other would be a decryption key with which you will be decrypting your data. Also, I would like to mention that in public key cryptography, the encryption key is of public knowledge, meaning uh, if you are the receiver of some kind of information, you have to act as a receiver of some kind of information. So the sender would use your encryption key to encrypt his data to send to you, and you will use your own decryption key, which is privately stored with yourself, to decrypt it back to get the original information. And some standard public key encryption schemes are RSL, Gamal, Rabin, and all. So now that we understand that the most pertinent question regarding data is to encrypt the data, and this kind of thing is dealt with in the subject of cryptography. So the question is, what are the most challenging situations for cryptography? To be very specific, one of the most challenging situation in cryptography is key management, and I will try to explain why managing the key or keys of a cryptographic system or protocol is of importance. So this is something called as Kirchhoff's principle, which basically states that whenever we wish to uh, construct a cryptographic protocol or an encryption scheme, so everything about that scheme has to be of public knowledge except for the key that is being used right now. So in other words, it will be of public knowledge that what are the possible messages that are to be encrypted. Also, it will be of public knowledge that what kind of keys may be used to encrypt those messages. Moreover, it will be of public knowledge that what kind of encrypted text does it look like when we encrypt some text with some key. So all these things are of public knowledge except for the particular key that we are choosing at this moment to encrypt some data. So this is known as Kirchhoff's principle. So I would like to go back to the previous slide. So this is the motivation of key management. So now that key, which is not of public knowledge, has to be stored securely in some location with yourself. And there is a theorem called Shannon's theorem, which goes on like this. Say, if you have a space of messages, say M, and space of keys, say capital K, and space of possible cipher texts, say capital C, where you can choose any key arbitrarily, uh, uniformly arbitrarily over an uniform distribution, then that scheme will be perfectly secret or perfectly secure if and only if for every plain text and every ciphertext pair you have a unique key that maps that plain text to the given ciphertext. So in other words, number of keys possible is actually at least, let me simplify my statement. So the number of possible keys that you need to consider is at least as large as the number of messages that you have at your disposal. So this means if you want to store some message secretly, instead you are encrypting it and storing the key secretly, then you need at least as large space as the message itself to store that information. So that is why managing the keys is such a big challenge. So here comes the notion of secret sharing, and I will try to exemplify what I want to say. So suppose you have a secret file, and the notion of threshold secret sharing allows you to split that secret file or secret information into n parts, say S1, S2, Sn, and this way of splitting will be called share generation, keeping in mind that any threshold many, so T being the threshold, so any threshold many shares of the secret will be able to get the secret back, whereas if less than the said threshold number of shares are accumulated, we will be getting absolutely no information about S. And by saying absolutely no information about S, what I mean is that guessing S or guessing the secret without having any shares at all, and the probability of guessing correctly without in absence of any shares is actually equal to the probability of guessing the secret in absence of not enough shares. So by not enough shares, I mean not threshold many shares. So this essentially captures the flavor of two properties which are known as correctness property and privacy property respectively. And in 1979, Shamir and Blakely independently proposed two secret sharing schemes. So you can mathematically interpret this in the following way. Suppose you have a space of secrets where, so it is essentially the collection of all possible secrets that you may store. And so you can imagine this as the key space. So since we are concerned with storing the keys, you can imagine this is the space of keys, all possible keys, and you have a wizard or a black box which knows a way to split this into n parts, and corresponding possible collection of shares for the first participant will be called as the share space of P1 or the first participant, and the size of that space will be known as the share size of P1, and similarly for other participants. So this is a technical overview of how a secret was shared according to Shamir. So what he did was he expressed the secret as a point over some finite field, and he took a polynomial which satisfied this condition. So f of 0 should be the secret value, and that polynomial was of degree at most t. And what he did was essentially calculate f of I and gave it to the ith participant as his or her share. And the construction was done using polynomial interpolation. To be very specific, it can be done using Lagrange's interpolation, where given any t plus 1 points of a t degree polynomial, you can uniquely interpolate the polynomial back, and hence you can get the secret back. So this is the technical overview of Shami's secret sharing. And this slide is an example of a secret image. So all of this picture is very known to us because this is a sample COVID report, and as we may understand that our COVID report has, so if you are a patient and unfortunately you were affected by the coronavirus, and you had to take a test and it came positive or negative, whichever the case might be. So the report or a picture of that report is a confidential information, and using secret sharing scheme or image secret sharing schemes, you can generate 5 shares or shadows in this case, such a way that even, so this is an example of 3-5 image secret sharing, meaning whenever you get 2 of these shadows, you will have no information about the original COVID report. But whenever you accumulate 3 or more shadows, you will be getting the secret back. Whereas in case of 2 or lesser number of shares or shadows being accumulated, you will have a very random looking image as an output, which will give absolutely no information about the original secret, which was supposed to be the COVID report. So technically, this is how this is the flow chart or step by step pseudocode of the share generation protocol, and this is the recovery protocol. So now I will move on to the main part of the or main result of our of this talk. So you can implement these codes in Python or Sage or whichever programming language you're comfortable with. So this is a sample example of a Python code of how do we share an image. So if you look here carefully, k is chosen to be 3 and n is chosen to be 5, meaning this is an instance of 3-5 image secret sharing scheme, where it is done over a field of size 251, which is a prime number, and 5 shares are generated, which are stored as 5 files, share 1, share 2, all the way up to share 5. And the reconstruction takes 3 of these shares, say share 1, share 2, share 3. And if you look carefully, it has to invert a van der Waals matrix given by the line number 30. This is a van der Waals matrix having the rows as 1, 1, 1, 1, 2, 4, and 1, 3, 9. And you have to invert this one, and eventually you will get the original secret back. So now I would like to explain the adversarial motive in this scenario. So there can be two broad kind of adversaries present in this scheme. One would be the CDV model, where the adversary knows the secret beforehand, and the only thing he wants to do is to convince a participant of some valid but incorrect secret. And the OKS model guarantees that the adversary does not have access to the secret from other sources, yet he will try to gain similar kind of advantages over other participants by cheating them or deceiving them. And it follows from the definition of these models that the CDV adversary is presumed to be stronger than the OKS variant. Okay. So suppose I will try to show how in practice we can do this. So suppose we have a secret image, and while sharing the secret, instead of taking 1 pixel at a time, we will be taking, say, 2 pixels at a time. So we pixelate the whole image and take 2 pixels at a time and put it in the, say, suppose a0 was 2 and a1 was 3, and we construct this polynomial to share the secret mod 11. And we will be doing this among 5 participants, where the third, fourth, and fifth participants are going to reconstruct the secret, where the fourth and fifth participants may try to behave under the influence of an adversary. So first we generate shares for the 5 participants. So the shares are respectively 6, 1, 9, 8, 9. So they are given the shares, which are private. But of course, the fourth and fifth participant can speak among themselves, and they can discuss regarding their shares and all. So now they discuss among themselves, and they agree upon, say, this image to be reconstructed. So they want this to be reconstructed instead of the original image that was being shared. So what they do, they pixelate this image, and of course this has to be an image of the same size. And suppose B0, B1 are the first 2 pixels. Then during reconstruction, they wish to submit some shares which are compatible with the third participant's share, so that a new polynomial is reconstructed, which gives which yields the target image of their choice. So the question is, what should be their shares which they will be submitting? So in other words, they need to evaluate this B2 for this polynomial. And keeping in mind that the original share generation polynomial and the new polynomial should agree on an honest participant's index, because otherwise, since the honest participant is going to submit his actual share, the same value will be used in reconstruction of both polynomials. That is why f3 should be equal to g3. And by using this identity, we solve this equation by putting x equal to 3, and we will be getting b2 as 4 in this case. So now the cheaters have this polynomial, and now they submit g4 and g5 instead of f4 and f5. Also keep in mind that the third participant is submitting f4, which is also sorry f3, which is also equal to g3 as per our assumption. So now instead of f3's sorry fx's shares, we have gx's shares being submitted, and essentially the polynomial that is going to be reconstructed is gx, and Lagrange's interpolation will be used for reconstruction purpose. So this is a very small example of an attack uh, that can be implemented to reconstruct an image of our target or the adversary's target instead of the actual image that was being shared. So in other words, the actual secret which was distributed among certain participants is not reconstructed now. Now something different is reconstructed. So here the original secret is lost, and this can be considered as an attack on the secret sharing scheme or image sharing scheme. So I would like to propose certain open directions. First is the formalization of pixels versus cheaters trade-off, meaning in this case we had chosen 2 pixels at a time for an image being shared, and we had also chosen 2 cheaters among 3 reconstructing participants. So we can increase the number of cheaters, we can decrease the number of cheaters. Also, we can increase the number of pixels at a time and decrease that also. So we can there is a very interesting direction of this trade-off, pixel versus number of cheaters trade-off, and there is a scope of formalization of that as well. Another direction would be to propose some image sharing scheme which actually prevents this kind of attack or cheating detectable image sharing scheme. And the third direction would be considering the almost semi-honest model, where there is no restriction on the number of participants being considered. So participants keep coming, and the almost semi-honest model means that every participant can cheat the participants who came before him. So in this model, studying the notion of image secret sharing and attacking or trying to prevent that attack would be an interesting question. And we can also consider some other hybrid setups. So that's it. I would like to thank everyone for listening, and I would like to invite questions, if any.
Okay, thank you, Jyotirmoy, for this interesting talk. So, anyone have any questions? Okay, maybe, but I have some curiosity about this presentation.
Mhm.
So, uh, so far I have understand that you just use the Shamir algorithm, right?
Right. But there is a little tweak in that. So
Yeah, that's I could not understand. Why is the tweak, and what is the essence of this tweak?
so the main motive of the tweak is here. So in this example, we did consider 2 pixels being taken as a secret at a time, whereas among 3 reconstructing parties, 2 cheaters could come and try to attack one single honest participant. But um if you recall, there is a paper by Tompa and Wall where a single participant could do a similar attack where one secret was being one coefficient of the share generating polynomial was taken as a secret value. So since in the notion of image secret sharing, there is the literature allows to take more than one. Even some cases, all the coefficients or all but one coefficients are taken as pixel values or some function of that pixel value. And we can also, we have seen that if we increase the number of cheaters, the cheaters succeed easily, that is fine. But if we decrease the number of cheaters, it is actually difficult to attack, because you have now lesser number of equations to solve, whereas you have more number of variables to evaluate. If you look at this screen, I would like to, so the target of the cheaters is to find this b2.
Yes.
Now if you consider a bigger polynomial, higher degree polynomial, where lesser number of points are being taken as pixel values, so there will be more b2, b3, b4 like these unknown points, whereas the cheaters will have lesser number of equations like f3 equal to g3 to help them. So this is one kind of problem. Another kind of problem is if you have more of these equations, f3 equal to g3, if you have more equations but less number of variables, now all these equations have to be compatible with those variables. That's another kind of problem. So this is the main motivation of this direction.
Okay. But we have seen multiple times this kind of technique in respect. That's what we have told in CDB model and OKS model. But essentially, we used the same kind of thing. But I think, in my understanding, if I'm wrong, you may correct me, that you are studying the technique actually in respect of image, right?
Right.
Okay. So thank you again, Jyotirmoy, for your interesting talk and for your explanation. So next, we will move to our second talk of this session. The title of the second talk is Corrective Yoga of Spine, Psychological, Anatomical, as well as Graphical Representation. The presenter is Dr. Shopan Kumar Odhikari. So I would like to invite Dr. Shopan Kumar Odhikari to present his work.
Hello, respected President, sir. I want to present my paper, which is Corrective Yoga of Spine, Physiological, Anatomical, as well as graphical representation. Yoga can be classified in different ways. I have taken only corrective asanas. Asanas mean postures. I have taken Chakrasana and Dhanurasana. And there are different types of yoga, cultural asana, relaxation, and meditative, etc. Along with that, we know the respiratory asana, which is more popular today, that is pranayama. That has not included. I have only taken two asanas, chakrasana and dhanurasana. We know yoga teaches us essential activities for our health and happiness. These health and happiness always exist in our body system. And most of us are acquainted with the fact yoga is unification of breath and mind. Breath has been treated as prana in Sanskrit, and I have to clarify that. According to Hatha Yoga Pradipika, mind and prana means breath, are like combination of milk and water, which is inevitable, but perform the activities where pranic movement actively unified with the mind. Mind means consciousness here, and vice versa. Prano can be defined to blow and to live. Blow means inhalation and exhalation. It is used for nourishment in living being by vital air, inhalation of air. Vital air as an amount, and that can be demonstrated later on. Universally, it is manifestation of all creative forces of life. Our mind and body depend on inhalation and exhalation. Therefore, we will be immensely benefited and able to think more clearly and move efficiently on the basis of breathing effortlessly. Clarification of prana on physiological viewpoint. In living person, air enters through the passage called trachea, which is within our throat. It is a continuous process for each respiration where breath is a crude sign of life. Prana is vitality. Vitality is difficult to define, but we can understand it. It is nothing but an external respiration, whose outward in manifestation occurs in the chest, what we see regularly. Another kind of respiration also exists, called tissue respiration, occurs within the cell membrane. At the cell level, energy bonding and its utilization done by process of helical linking in presence of that heat can be estimated by the following formula, where this helical linking were first directed by Leonardo da Vinci in his anatomy book, where he says spirally is human. That is, all the parts of human body are in spiraling nature. External respiration is either way of transport system of oxygen and waste gas, exchange of oxygen and waste gas. This random motion of air molecules constitute additional energy. This outgoing and ingoing constitute additional energy. Here I can present a graph. Here different parts of respiration have been of them have been explained. Vital capacity is the most effective, and that is prana. Its volume is nearly 1700 ml. But we see that in the graph, some are smooth and some are actually more than that, which is can be expressed as more expression, that is forced respiration. In some time, we have to use the forced respiration for our body needs. Total volume of the lung capacity is nearly 3500 ml in India. Therefore, it contains some reserve area, reserve volume, that is nearly 1200 ml. That cannot be expelled and cannot be filled up. That is always remain within the body. Of them, this vital capacity plays vital role to give us the energy. During inspiration, a negative pressure created at the lungs, that is at the pleural sac, by respiratory effort of muscles, and that draw the air into the alveoli. Alveoli are very thin space where oxygen mixed with the blood and carbon dioxide is let going out, and that is within the lungs. And this method is always keep us fit. Practicing, what are the effects of practicing yoga? Proper way of yoga practice is to establish integration of mind, breath, and body. It is also necessary to establish integration of mind, breath, and body. It is also necessary to establish integration of mind, breath, and body. It is also necessary to establish integration of mind, breath, and body. It is also necessary to establish integration of mind, breath, and body. It is also necessary to establish integration of mind, breath, and body. Practice of yoga initiate to destroy impurities, both physical and mental. Light of awareness, dawn and discriminating intellect and sharpness and awareness born. In ancient concept of India, yoga is removal of obstacles that impede the natural functioning of our system. Yoga is accomplished by asanas, that is postures. I have taken two asanas. It is the chakrasana. It is the wheel posture. It requires combination of sacroiliac nutrition. That is at the hip, moderate hip hypertension, and lumbar extension enough to strain the arm push up into the posture. That is, in other words, prawn structure and back bend created by the spine moving extension by the action of several muscles who are responsible for this action. This is the actual structure, and I have given the names of the muscles who are effective in this posture. Benefit of this performance: lifting the spine into the back bend against gravity. We are lifting ourselves against gravity to perform a prone, that is face down position. It's rich pose that has numerous benefits. These open up heart and chest, helping breathe deeper. Deeper structure I have shown you already. Chest and shoulder muscles as well as a hip flexor, tendon, hamstring, spinal extensor, spinal flexibility, and to improve the muscular strength. Ultimately, it is energy boosting pose. Stretches chest, lungs, and strengthen other arms. Breathing, only inhalation and exhalation are allowed because heart should be pumped properly to give supply of blood to the active muscle. This is the total muscle activities. This figure shows the total muscle activities of this posture. Arrow indicates the turning, rotating, and these are the translation as well as rotational force within the body by this posture. And this is the bone effectiveness in this posture. And previous one I have shown the muscle involvement within in the posture. This is anatomical representation of this posture. First one is the shoulder deltoid muscle, which drag the chest forward. Second one, contract the hamstring muscle. Here you see contract the hamstring muscle, and here there is rotational force. And here also, this is extension and this is contraction to come into the posture. Here also is anatomical representation. The internal rotation has been done at the femur, that is thigh bone, whereas these make the foot away. This is an anatomical representation by parts. Internal rotation of the hip. This make internal rotation of the hip. And this both, this weight, in this posture, the weight actually affects the ball. Here there is a ball, and which make the leg attached with the mat. These are also anatomical representations. Due to stretching of the keep, hand away. Here, these forces, and this was a contraction, and this is upward lifting. Make hand and legs away to feed ourselves on the mat to make us actual in the fitted position. This is extension of a hip joint. Here there is rotational force. And here these positions make our chest extended to make our breath effectively. This is the actual position. And this is the how this effect breath is coming out. Here is a hypertension of the lumbar vertebra, etc. Actually, there is a hypertension curve on the lumbar vertebra and the curve on the chest is in this way. I have taken, it is the parabolic structure. It is the parabolic structure as it should be the smooth curve for the better flow of the blood and etc. Here is Dhanurasana. It is taken as catenary. There are three stages. One is Saral Dhanurasana, that is easy bow pose. This is Dhanurasana, just like a bow. And this is the active bow pose, Purna Dhanurasana. And these indicate a easy bow is only the card. And this one represent actual bow. And here the legs are near the ear or on the head. And this is when we are triggering by the arrow, and this will be the position. Therefore, different stages of dhonu has been mentioned here. So it is dhanurasana. This is the muscle activities of this dhanurasana. Here also anatomical representation you see. All regions of the body work together here. And here is rotation at the shoulder. Here you see rotation at the knee. And these affect the rotation of the hand here. The spine is fully extended here. And knees and bent elbow, etc. are restricted to the ribs. Here this bending is restricted because ribs make our spine stagnant. Here also anatomical representation of Dhanurasana. Here you see head is coming near the spine. Here is the arrow and there is rotation. Here also when we are dragging by the hand, it will rotate. There is also anatomical representation when hips are coming close and hamstring muscles are near to the hip. Here the activities of the shoulder, here is rotation and hand is going straight near the upper portion of the hand. When we are drawing the leg, then the deltoid muscle will rotate. And actual representation of all the muscles is this. In conclusion, we say smooth curves indicate initiation of smooth flow of the fluid within the body under these postures. A relatively smooth curve that moves evenly through the whole spine without becoming a hinge and without becoming a hint that it is moved at any part of the spine. Activities of the muscles are increased to have a proper tissue respiration to active within the muscle. Yoga is considered to be the living science under the experience and experiment on the basis of truth of the science by succession of experts. Therefore, we can say yoga is that art and science which is calculated on to ensure an individual's perfect health for the body and his inviolable happiness for the mind and perfect spiritual development of the soul. And these are references. Thanks, sir.
Thank you, Dr. Odhikari, for your nice presentation. So if anyone have any questions, please raise your questions. Okay, I think everyone have some idea about your nice and user presentations. So thanks again to the speaker. So now we will move to the next talk. The next talk, title of the next talk, Color Theory, Basic Color Models 8.0, Basic Music Theory 3.0, Magnetic Field Orientation. The speaker is Dr. Carl Schupp. So I want to request Dr. Schupp to start your presentation.
I'm here. I'm getting queued up.
Okay.
I'm still waiting for the program. Do you see anything?
No, we cannot see.
Yes, we see now.
Do you see it now?
Yeah, there's color theory, basic color models.
Okay. All right. I'm ready to go. My paper is Color Theory, Basic Color Models 8.0, Basic Music Theory 3.0, Magnetic Field Orientation. There are 6 primary colors and 6 primary color interfaces. The primary colors are red, green, blue, RGB or cyan, magenta, and yellow, CMY. In a defined color system, there are 3 or 6 primary colors. You'll have RGB or cyan, magenta, and yellow, or RGB and cyan, magenta, and yellow. This color research has used numbers and geometry to identify primary RGB, CMY, and RGB and CMY references. RGB and CMY equilateral triangles, one inverted to the other, are used to identify the color hexagram geometry. The 6 points or peaks of the color hexagram are used to identify the 6 primary colors. The 6 valleys between the 6 primary color peaks are the primary color interfaces. This identifies 12 color reference points per the color hexagram geometry using numbers in 2 primary colors from its group, RGB or CMY, can be combined to identify a numerical value of the 3rd primary color within its group per a balanced equation. Per the geometry of the color hexagram, color interface values are obtained when maximum values are adjacent primary colors or peaks are combined to identify the maximum value of the valley between them. This color research has demonstrated a correlation to basic music theory. A color system with 12 color references correlates to the 12 primary tones of the circle of fifths and the A440 method of tuning. Basic music theory identifies 9 chromatic octaves per the halving and doubling of the A440 reference. This color research identifies 13 color octaves within the range of audible sound per the harmonics of the Jacob's ladder. Jacob's ladder includes the entire range of sound, which are mechanical waves, the entire range of the electromagnetic spectrum, which is radiation, and introduces the concept of basic music theory to all vibrations. So what music theory introduces is an order and a clocking of frequencies, and that the octaves that are identified in my color theory are the same as the harmonics of Jacob's ladder. With the identification of 12 color references, this color research proposes a correlation between figures 101, rotation system 0 to Earth's magnetic field, and figure 102, circle hexagram showing unit circles and Pythagorean circle of fifths color wheel, to be representative of a static magnetic field of the Earth and its orientation. A little background, real quick, is that in doing the research that I'm involved in, that what drives my research is to have I'm just going to call it a big crazy idea that I'm trying to prove, something that I think is kind of impossible. But my original big crazy idea was to be able to identify color in some way using numbers and geometry. And I'm a bit beyond that now. So what's driving my research right now is I'm trying to figure out how teleportation works, or portals. And I'm also trying to figure out how to do magnetic levitation. And that the basic color theory paper, basic music theory #2, was about the orange hypothesis, because within a spectral display from a prism or a rainbow, orange is included in those 7 colors. And to advance my research, I had to figure out where is orange coming from and what does it mean to the color system. And there's a reason for orange, but it doesn't impact the color system or music. So talking about theoretical applications of my color model, that I have come up with a certain number of assumptions, and that is just setting the ground for me to go on with my research, so that if something doesn't work out, I can go back to my assumptions and hopefully adjust the assumptions and figure out what's going on. But based on a time limit, that I have a short version of my paper and a longer version, and that what the shorter version does is it gets to the point right away, and the longer version identifies other things. And to have that big crazy idea is that it leaves the possibility open for me to make other discoveries on the way trying to get to that impossible idea. So this basically is something that I'm going to repeat in a little bit in the lecture version of this paper. But what we know about our static magnetic field around the Earth is generally just represented by a bunch of brackets. It's a symbol. But what's going on inside that magnetic field, and if you've seen a coil of wire and metal scrapings form, the typical arcs with a magnetic field, it doesn't really tell you what the mechanics are. And so what you need is to understand the mechanics in order to develop concepts or ways in which to use something. And so with the Earth's magnetic field, it's at 349 degrees. Its North Pole. It's about 11 degrees from the North Pole. But with color theory, that for music, that C is always at the top and F is always to the left at the 11 o'clock position. And with color theory, my red anchor is always at the top, and my system zero, is always 1/12 of the total range minus my primary red value. So I saw a correlation between music and my color modeling. And now I'm proposing that there is a correlation as well between the Earth's static magnetic field and with my color modeling. So that's what's going on with that. And I'm going to shoot ahead to the lecture version of the paper, which has the same things at the beginning, but it expands on other concepts. So like with my two-dimensional representation of my color modeling, that there's three-dimensional versions of the geometry. So where I use equilateral triangles, the three-dimensional version is a tetrahedron. Where I'm using hexagram, the three-dimensional version of a hexagram is a star tetrahedron. And then a circle is a sphere, a square is a cube. And then the geometry that I'm getting into more so is a circled hexagram, and what I'm calling a circle flower of life. So again, in order to determine where the magnetic and north and south pole is, that the system uses compasses. We have to use a compass to make that determination. And so what I'm proposing is that once we establish where the magnetic north-south pole is, can we just, going the wrong direction, can we just align this figure with the established magnetic and magnetic north and south pole, and the mechanics, the color theory that is employed here, along with the music theory, would that explain the mechanics that are involved with the static magnetic field? And that with studying electromagnetic radiation, we tend to focus on the electric field. What is electricity doing? But it's electromagnetic field. And so you also have a magnetic potential. And could that magnetic potential define what the north and south magnetic poles are? Is just a magnetic potential. Or can't really say it's just a magnetic potential, but it is a magnetic potential. So what this will do, and where I'm going with this, is that if I've defined the geometry and it's a known geometry, can I use that geometry and relate it to the Earth's magnetic field so that you can identify what the energy levels are or what the magnetic situation is, at a particular point. And this gets back into floating on the Earth's magnetic field, like a balloon floats on the Earth's atmosphere. And this is a representation of a cube where the top right corner is in line with the rear bottom corner. But you can see that the hexagram fits in there, and that I've calculated numbers. These are all proportions. And so if you have values, and NASA and ESA are doing surveys right now to measure the Earth's magnetic field in various places. If you can put that information in, and if it correlates with the proportions here, that we could have a working model of how the Earth's magnetic field works. There's also research that's being done on electromagnetic or magnetic reconnection. The research is referred to as X points. And with X points, that the data that they've received implies that there are portals opening and closing in the upper atmosphere of Earth, where the Earth's magnetic field and the sun's magnetic field is interacting. So if you have an understanding as to what's going on, the mechanics of the magnetic field and how it rotates, and you understand how the sun's magnetic field is operating, the Earth rotates once every 24 hours or one in a day, and the sun rotates on its axis once in, I believe, about 36 days. And so that interaction, Earth's magnetic field, does Earth's magnetic field act like a bell? So it's static, but can something that impacts the Earth's magnetic field cause it to respond, to ring? And that could also include things like solar flares, coronal mass ejections, even an airplane flying through the Earth's atmosphere. What impact does it have on Earth's magnetic field? I have assumptions, and again, to read the assumptions will take a lot of time, and I'm trying to stay within my time limit. And this is just more calculations that I was doing using different color patterns. One color pattern is the linear string of 1, 2, 3, plus or minus values, in little phi, 1, and big phi. Each value here will make a circular constant, and that is based on the 10x circular constants that I invented. And they require the use of the long second time base. And the enigma that I ran into is that I had a new number introduced here, and that's something I'm still working on, trying to figure out what's going on. So the geometry that I'm working with, that the primary colors can be referenced by the points of a hexagram. Three-dimensional version of a hexagram is star tetrahedron, or circles of colored light. And that the way this is working, this can talk about color separation or color combining. So things expanding out, you're separating color. And if you combine it, when all 6 are combined, the center circle is white. So I'm talking also about space. So this is normal space, and that what happens is that unique orientation where you're looking from the top front corner to the back bottom corner, the coordinate system changes. And I'm still working on that. It appears to be a case of magnetic lensing. This only happens with what's here, but per the drawings don't really tell you other than it's a wireframe drawing. But what does the wireframe drawing actually represent? And it could be it's just a wireframe drawing, or it could also be representing just space. There's nothing there. There's just a set of coordinates that are talking about a cube space. And where this ties in is that I was able to identify Metatron's cube. So Metatron's cube is one of those ancient symbols that either tie to the, I guess he was an archangel, Metatron, but this has a relationship to portals, and nobody really knows what it's about. And I'm approaching it from an engineering standpoint, and that, okay, what is this telling me in a engineering sense? And I'm approaching this as it being a schematic and nothing metaphysical or anything. This is a schematic, and that the smaller cube is actually behind the larger cube, and it's not a tesseract, but what's going on here, and trying to make a connection to it. So back to my cube now, and you can even imagine it's the smaller cube here, and its coordinate system and its orientation. So where the coordinate system shifted, I came to a different model to where I'm combining colors. And one thing that I realized was this is Metatron's cube. So what I'm looking at here is Metatron's cube. I've got my 6 points as represented by colored lights, and I have another 6-pointed symbol or image that, again, I can convert that to a cube. So I've got a cube within a cube, and I'm talking about Metatron's cube. But what this additional information tells me is when I'm combining blue and green, I'll get red here, and cyan, I'm on the other side of cyan, so that'll be red also. But the orientation is I have a red opposite a cyan. They are opposites of each other, and opposites attract when you're talking about magnets, for example. And that it tells me that the orientation of Metatron's cube, that inner cube could be in this orientation. And another thing that kind of jumped out at me is that if I'm talking about the Earth's static magnetic field, then what's this inside? Is it another magnetic field? Is there another magnetic field inside the Earth? And so again, that would be a thing that I'm gonna be paying attention to see if research along the way identifies an internal magnetic field that the Earth may have. And this is just another reference to show that these colors aren't interfacing, and I need to move on. So again, this gets into music theory, just talking about how things are organized and how the tones fit together. And knowing that we're talking about a hexagram or star tetrahedron or a cube, then rotating that known geometry isn't going to change the geometry physically. You may change its orientation, but you're not going to change the geometry. So I'm back to looking at my cube, and I rotated that cube so that it aligns with the Earth's magnetic field, and put the magnetic field back around it. So the question is basically, can I rotate that whole sheet of paper to align with the Earth's magnetic field or with any other magnetic field? And as a result, would I have done a basic mapping or color mapping or tonal mapping of the Earth's magnetic field, or say the sun's magnetic field. So the technology gap that I have is that how strong is the Earth's magnetic field? I know it goes out thousands of miles, but at what rate does it drop off? And the potential here is that if you could build a platform that you can detect what the Earth's magnetic field is directly below you and duplicate those characteristics with something that generates a magnetic field on your platform, will you be able to float on Earth's magnetic field? The International Space Station flies, it's orbiting at about 240 miles or 250 miles above the Earth. Is it possible to create like a space elevator? And if the Earth's magnetic field goes out to several thousand miles, is that good enough? Could it actually be used as a means of propulsion? I don't know, but that's where I'm going with this. And one of the things I found on my way to what I've done so far, another thing that I've been trying to work out is radiation mitigation. And mitigation just talks about the lessening of an effect on something. So how do you lessen the effect of radiation? So the Earth has been getting hit by solar storms, radiation, coronal mass ejections a lot lately. And how do you protect your power grid? How do you protect your satellites? If you're putting people in space, how do you protect, the people on board the spacecraft? And basically, how do you develop a radiation mitigation technology? And from music theory, that what I had identified was that we're in primary tone F. So our electromagnetic spectrum is in F. Our range of sound is in F. Music theory is in F. And so what does that actually tell us? And if we wanted to mitigate harmful radiation, and just using the concept of complementary colors, it may not be that we have to find the opposite frequency. It may be the opposite tone that we need to build things in terms of length, vibrations. If you think of a bell ringing, that when you strike the bell, it's tuned to B, primary tone B. And if it gets disturbed by radiation, for example, from a F source, it will ring in B. And would that cancel that harmful radiation? And pretty much all radiation is harmful to us. So we can tolerate relatively high quantities of just white light, but if it becomes infrared or ultraviolet, we end up getting burned. So in summary, I just want to say the organization and the structure of Figure 101 will not change if Figure 101 is rotated as a unit to align with the magnetic north and south poles with the magnetic north and south poles of the Earth. If the basic concept of Figure 4.0.1 is valid, then the clocking of Figure 4.01 to match the orientation of Earth's magnetic north and south poles would involve the rotation of the 330 degree position of Figure 4.001 to align with the 349 degree position of Earth's north pole. Historically, Earth's magnetic pole and south pole tends to wander about for whatever reason. But if you can determine where it's at, can you do this alignment? There's a east and west element to the position of the Earth's magnetic north and south poles. If moving the 3D version of the figure 4.0.1 to align with the magnetic north and south pole of the Earth is valid, then the east-west elements would be accommodated. But there is no east, west, north, or south in outer space. So using this concept on something that's in outer space would have to be worked out. And these are my references. And that's it. I thank you for your time.
So thank you, Dr. Shuf, for your nice and elaborate presentation. So if anyone have any kind of questions, please, it's your time to ask to Dr. Shuf.
Carl, thank you very much for your kind presentation. So I can note the evolution of your theories from color 1.0 to now it's 8.0, and from music 1 to now 3.0.
Yes, it's
Yes.
growing.
Yes, it's growing nicely, and every year you come up with new ideas, and it looks really nice. Hopefully,
thank you.
Next year you will also join with us with some new of your new numbers like color model 9 and then maybe 10 on the same conference maybe.
I sure hope so. Right now, I've got nothing. I have no idea what I'm going to talk about, but I'm going to keep working.
You have only one more year to think.
That'll be enough time.
Yes, great. Yeah, so
thank you.
Thank you. Yeah.
So yeah, thank you, Dr. Shuf, for your nice presentation. So our next speaker, Professor Shurit De. So title of the talk, Eigenvalue Analysis of a Nonlinear System of Differential Equation. So I want to request Dr. De to start your presentation. Professor De, you are muted actually.
Yeah, Professor De, can you hear us? You are muted. Can you please unmute yourself on the microphone button? Can you please click on the microphone button on the bottom? Yes, now we can. Yeah, great.
Can you hear me?
Yes, now we can hear you. Yeah.
Okay. Over here, how I'll go back to my paper is in Google Docs. Can you load that?
So is it open at your end? Can you see on your screen the Google Doc paper on your screen?
I have to start the Google Docs. Just a second. Chat. Can you open mine from your end?
Let's see. Just a minute.
Let me see.
Yeah, I'm just going to forward you the email. Then you can very easily find it.
Then I have to close this window.
No, I have just now forwarded you this.
I got it.
Oh, okay, great. Yeah.
No, I can find it.
Okay, I have just forwarded you this.
Oh, wait a minute. I have to go back.
Okay, or I can open it and share it for you. if you
Please do that.
Yeah, if you don't mind. Yeah, so
No, that's okay.
yeah, then I will share my screen.
Share your screen.
Thank you.
Yeah, can you see this?
Of course I can see this. I can see this pretty well.
Okay. So you need to tell me when to scroll down and all. I will do
You
so.
scroll down. Right here. Stop right here.
Yeah.
Stop right here. This is rather a simple article. But this article, regardless where I went, people asked me about how we analyze. This should be du dt equal to. Is that equal to? Equal to fu. Yeah, there's a sign of equality. We are solving a system of nonlinear equations. These are nonlinear differential equations. This complete article you will see in my book on breast cancer treatment, when I discussed various different kinds of methods that we applied to solve the models. But the problem is, people should know not how we solved it, but why did the method work? If you use a method to solve a differential equation, that does mean the method will work unless the method maintains its stability, its computational stability. And in the case of nonlinear systems of equations, maintaining stability is a big headache. Often you write the code and you submit, or you use a package. There's lots of package, but a package doesn't mean anything because method may not work in your particular problem. So you have to analyze the stability. In the case of models related to, biological systems in physiology, or like the cancer treatment that we talked about, that one, or fluid dynamics. Fluid dynamics is comparatively easy because those systems are mildly nonlinear. But in biology, especially to study cancer, you will see, whereas the cancer cells are going slowly down sometimes, but later it goes up real fast. If you see a number of variables doing strange behavior, then it is highly nonlinear. Nature is nonlinear. To study nature, when we linearize the system, in most cases, we lose a lot of information. Therefore, your data, which you find by using experiments, and your models, they do not cooperate with each other. And that was a big challenge for us. So we had to do the analysis of stability. Can you scroll down a little bit? Abhishek Babu? Yes, stop right here. What we do in general, we go down a little bit, Abhishek Babu. Go down a little bit. Yeah, down a little bit down. Yes, this is the equation. Can you all see this equation? Abhishek, can you see this?
Yes, equation 6.
Equation number 6.
Yes.
Equation number 6, you see, is a very simple equation that we always deal. And this is the equation which in our classes, of course, we didn't discuss this way. But when I went to NASA, this scientist, they said, Suri, try this first. And this is a very simple equation. This is a linear equation. It's a du dt. U is not a vector, is equal to negative lambda u. And before you try any method, numerical method, to solve the system, before you try, you have to see whether the real part of lambda is negative or not. If it is negative, then your method will be stable. If it is not negative, your method will be unstable, which means you will get wrong results, completely wrong results. And in fact, as time goes, what will happen that you will see the method is diverging, exponent overflow, computer will stop. The question is, when you extend this concept to a system of equations, nonlinear equations, then how can we know that the method will work? Like, can I drink little tea? This is morning. Tea is good. Now, therefore, Abhishek Babu, can we go up a little bit now at the very beginning? Yes. Now, what we did is you saw that f of u, all the details are in my book. I wrote in details in the book. Now, what we do, we linearize the nonlinear system at a particular instant, which is t sub n. And every time we linearize and solve at that particular time step, we solve at every time step, we linearize, we analyze the stability of the system. Now you understand, we are solving, I solved 5 million equations. Means huge number of systems. It's a huge, huge computation. It takes sometimes half of the night before I could get the results. I'm an old man, but I do wake up. Now, we linearize and we represent the system as du dt equal to au. But be sure, a is a function of time and b is also a function of time. And a is f prime u sub tn minus 1, which means this is the Frechet derivative. It is the, if you think of the determinant of the first order derivative, that determinant, you think that this is a matrix. And that is A. Now we have to see what A will lead by looking into the instant eigenvalues and eigenvectors. The solution, as I said, will depend on the eigenvalues, and the eigenvalues, the real part of the eigenvalues, must be negative. We are solving in a real time. Now, when we go into A, which actually a function of time, the matrix is changing at each time steps, and we have to analyze a 5 million equation, which means a system with 5 million rows and 5 million columns. And we are finding the eigenvalues and eigenvectors, mainly eigenvalues. Now, can we do, now, for this system, at that instant, the solution is this, given by the equation 4. Now you see C sub j, I'm doing it j equal to 1 to j equal to capital J. Capital J means that 5 million. So a huge system we are solving. Now, here is the solution, theoretical solution, not the real solution. Real solution we'll get from the computer. This is the theoretical solution. And we write it down that we will now go and look at the eigenvalues of A. Now, here, from here I see that if we can do that, and these are all assumptions. In the real world, whether it will happen or not, we have no idea. We have to compute. And the measure of stiffness. Stiffness means when you're solving, say, you're solving a system U and V. U is unknown, V is unknown. And you see the results, experimental results, that U will go up and V is going down, which means U is going up in the case of cancer cells. The cancer cells are increasing. And V is our protective system, means our immune system. Immune system is getting defeated as time goes, when things are getting worse. If that happens, how we can stop that? What kind of medications will be needed to stop it? Therefore, those medications, to know the effects of the medication, we will use them in such a way that as you go up, medication will slightly rise and bring you back, which means you will go down. So if it goes up, goes down, that is stiff. Therefore, it needs special treatment. It is not an ordinary system of equation that we will solve just using a package. In general, most times, packages will fail. Now, Abhishek, can you go down a little bit? Now, how we will transfer that system into another system such that we can look into the equations in terms of the eigenvalues. Abhishek, go down a little bit. What we did is at this instant, this M must be the modal matrix. The spectral matrix is lambda. Lambda, the spectral matrix means the eigenvalues, all the eigenvalues. It is a diagonal matrix, spectral matrix, and M is the modal matrix, means the vector, when you consider all the eigenvectors, put them in a matrix form, this is the modal matrix. Now we consider the spectral matrix, which I don't know right at this moment, assuming the spectral matrix with the modal matrix did a similarity transformation. And when I did the similarity transformation, the equation will look like this. D of M inverse X slash dt equal to lambda, which is the spectral matrix at that particular instant, at the time step, times the modal matrix inverse X. Now, if you consider, if I say that this is U and this is U, then this will look like du dt equal to lambda U. And that's why the NASA scientists, they made a simple version of it and looked like that. This is the simplest version. Therefore, we will look into this and analyze that. But this, we can look into this in my office. and we'll analyze that in the supercomputer. Can we go down a little bit, Abhishek? Now, I will give you an example. And this example we did during the COVID time. That's in 2021, which was last year's. Yeah, early last year, that's what we did. This is X. X means the stupid COVID. That's the system. And there are the medications and dosages of medications. I do not know all the details. They gave me this model and I solved. And these are the two simple equations. Actually, it was given to me by Charlie, my son. He works at TAC, Texas Advanced Computing Center. Over can we go down? Can we go down? And I solved. See, this is the determinant. This is the Jacobian matrix, we say, which we invert every time. Here it is only 2 by 2, but actually it is not 2 by 2. Go down. And then we computed, just a second, can we go up a little bit? Go up a little bit. Look at the eigenvalues. The eigenvalue, there are two eigenvalues. One is lambda sub 1, and the eigenvalues are changing, remember. One eigenvalue is negative 0.009035, and the other is negative 1 point. That means if you divide the largest one by the least one, then you see we call it the stiffness. How stiff is this? This is the stiffness. This is not too stiff, but this is stiff, which means it is difficult to solve this system by ordinary, like you know Range-Carter method. You know many other methods, Adams-Basforth method, and so on, many other methods. But 99% of those methods fail to solve this system. You go down, Abhishek. Now you see the result. You see one goes this and the other goes that. This is possibly the disease. The disease is getting better and better and better. Means the germs or the virus, whatever is causing, the mixed system causing, that is going down, and the medication slowly is decreasing as the person is getting better and better. And therefore, we solved it using our method. And the method I solved, that is published in many journals in the past. I do not know in India. Maybe in India it was published years ago. It's called PFI, Perturbed Functional Iterations. And we solved at every single instant, computed the eigenvalues, and got the results. And then if you put the results together, it will look like a movie. The disease first started, you cannot see that particular area. At first it started increasing, then it started decreasing. And I hope it will keep on decreasing and the person will be better. Abhishek, did I complete it in time? You have any questions? Please feel free.
Yes, we have plenty of time.
There's plenty of time.
Yes, so you can even elaborate a bit more.
If anybody has any question, I request all of you. Unfortunately, my book is pretty expensive in India. Here also expensive. It's about $120. But I think university professors can buy this. This is published by Springer Verlag. It was published this year in March. I request you to get hold of this book because those who are in mathematics or those who are in bioscience will find this book pretty useful. I made some modifications because my method PFI was taking a lot of time. It was solving implicitly, which means every time it will see the matrix, huge, 5 million by 5 million matrix, which is huge. Therefore, you have to break it up and then you can solve. It is pretty hard task. What we did, I broke it apart, one system, another system, another system, a number of systems, and solved all the systems at the same time and then put them together. That's what we did. And that's possibly what you have to do. But my son Charlie developed a method, a very interesting method, a lot simpler method. His articles was published by NASA many years ago, but now it is available in some books also. It's called Charlie's method. Now, what he did, it is partially implicit. Implicit means solving by transformation of matrices, partly, but partly explicit. It moves fast with time. Therefore, it helps students to apply the method in their practical problems. That is one thing that I like to say. And the other is that to solve this 5 million by 5 million systems, and we have a number of systems actually. It is not the only equation. I solved, I think, like 13 equations at the same time, by 13 systems. It is very, very time consuming. I'm sure you have access to computers which are very high speed, large system solver. And I think if you can do that, you can use that, then possibly I want you to read this method. You are mathematicians. You all should be able to read it and understand. And if you have any problem, I appreciate that you will talk to me directly. You send me an email. Abhishek knows my email, and Abhishek can send these to me pretty directly. And then I will talk to you, or we will do Google Meet, and I'll explain to you how this method works. I think you need this method. Unfortunately, all the packages which are available, unfortunately, they are applicable in very some of the cases which are what we say in our way of saying pretty simple system. There people use packages. I request all my students, I did all my life, you write your own package. You write it. When you write, you understand how it works. When you use somebody else's method, then you do not know how that method will work. Method may work, may not work, and you get frustrated. I will tell you one sad thing, very sad thing, these days which I see, that our students here, our students want to bypass mathematics. They want to use computers and they think they are using what is called, Charlie asked me, my son, asked me to read deep learning. I said, certainly I will. And I read. But problem with deep learning, be sure to understand, my friends, be sure to understand. In deep learning, they are using linear transformation all the time. Therefore, at every step, there are minor mistakes. And you can see a simple table how mistakes can propagate. Ultimately, when we get to the solution, whether the solutions will be valid or not in the real world is a big if. I request all the students to go into nonlinear system, read Abhishek's books on the books that he wrote, the beautiful books that he and his father wrote. I request you to read topology. I request you to read how nonlinear systems work. What is the mathematics behind it? And here in this country, many mathematicians are very much frustrated because younger students are very much interested to simplify mathematics and to learn computer a lot and use computational systems which are available in your computer and try to solve problems of the real world. Unfortunately, I will tell you, it does not work. At the end, there will be lots of mistakes. And in case of cancer, in case of treatment of sick patients, this could be a dangerous mistake. Absolutely dangerous. Because your medications and the response from the disease, from the person who is sick, the response could be very, very different. And I urge you to go into mathematics, not to study more mathematics, not just computer system. Computers we all can learn easily. Any mathematician can learn those things very quickly. Like I personally learned deep learning very fast. And I told Charlie it is very simple. It is not hard at all. I request you, I urge you to do more mathematics and analyze. Nature is non-linear. You cannot solve the real world problem by simple methods or simple computational treatments that you see in the packages. It will not work, my friend. You have to use deep learning through mathematics. Any question? Mathematics comes first, then anything else. And if you go online, you will see I wrote that my religion is mathematics. I preach it, I promote it, and I practice it. Mathematics. And thanks to Abhishek, he wrote a beautiful book on topology. Please read that. You have any question?
So any question?
Feel free. Feel free.
So I have already shared the email ID of Professor Shweet Day. So it's on the chat box. If anyone needs any query or any question, if you want to ask, you can send directly to them.
You know,
Yeah. So,
at least I will tell you there are many books available. Beautiful books written by great mathematicians. And please put more importance into mathematics and less importance to computers. We all mathematicians, everyone can learn all those computing systems very quickly. They are not hard at all. The language may be very different, but we can pick it up.
yes. So thank you so much, sir, for your kind and very energetic
You're most
words.
welcome.
Yes.
Have a pleasant. Now it is evening your time.
Yes, it's
Have a
now
pleasant evening.
8:13 in the evening. So I'll just go back to our session chair, Dr. Partho Sarathi Roy, who was there. Partho, could you please conclude the session now?
Yes, sir. Thank you for all the nice talks of the session. And I want to thanks all the speaker and all the attendee of this session, and now handed over the platform to the organizer, particularly Dr. Abhishek Adhikari, and please move into the valedictory session. Thank you all. Thank you.
Thank you, Partho. So Partho is now in Australia, so a different time zone. So what is the time now at your place now? It's
already 1:45 a.m.
Okay, so it's a pretty early morning. Professor Sweet Day, and I can see the Professor Manikam is already amongst us, and I can also see Curl there, Detrice there. So it's now we are going towards the valedictory session. So it would be nice if all of us will switch on the camera if you wish, so that we can see each other. Because during the technical talks, it's really difficult to switch on the cameras. But now, if you wish, you can do so. So very quickly, we will move into the final session of our conference, 3-day long conference. And Professor Manikam is amongst us. And may I now request Professor Manikam, who is a frequent visitor and one of the greatest promoter of this conference, who is one of the founder members and who is one of the key person of this conference. So may I now request Professor Manikam to chair this session. It's to you, sir.
Greetings, everybody. It's really wonderful to see all of you there. And I'm very pleased to see this conference started by Professor Maggie Madhigari, proceeding in an excellent manner under the leadership of Abhishek. Thanks, Abhishek, for doing this job. And, looking at the quality of all the papers and the number of papers presented, it is really, really remarkable. It has become really a true international conference. And only thing we miss is meeting everybody in person. I hope things will get improved. Maybe by next year, we may get together in Calcutta. I also miss the weather this time in Calcutta. It's very cold out here. The temperature is right now minus 17 degrees here. So I'm sure it's very pleasant in Calcutta right now. So that's another thing we miss, and hope we'll get to the next year in Calcutta and meet everybody in person. And thanks everybody for attending this conference, and I will let Abhishek take over and address the rest of the conference.
Okay. Thank you, Professor Manikam. So it's really a great pleasure for all of us to be here. And I can see many faces that usually we see on the conference, but really we miss this physical mode conference. So we are looking forward for the next year to have it in a physical mode. So till it's the 16th on the series. So every consecutive years we organize this one. Until 2019, we had consecutively on a physical mode, but suddenly this unfortunate COVID came to us, and due to that COVID for year 2000, 2001, and this year, we were unable to make it. So one of the reasons being for this year online conference is basically due to sudden death of one of the leaders of this conference, Professor M.R. Adhikari, who is my father, my beloved father. So we lost him last year, and the works that he left for us is basically writing up the books. So already 2 books on topology has been published by Springer. The 3rd volume was done by Professor Adhikari alone. But now it's my responsibility to check all the proofreads and all. So it's a huge task for me to look into all the things. So that's why, and also usually we plan this conference around 10 months back. So during that time, it was quite uncertain for everybody that whether during December this time, whether it would be okay or not. That's why we were in a double-minded mode. That's why we decided, okay, why not this year also to make it in a online mode. But I got many requests, many emails from many of the participants who actually visited us for for a long time. They are very frequent visitors to our conference. They all requested me to why not make it on a offline mode from next year. So I really looking forward for having an online mode next year. So you are all cordially invited to that conference, the offline mode that we are going to have. So we are also looking forward to have some monographs, maybe Springer proceedings, and a few Springer monographs may also come out for the next year, for which I'm already started planning of doing those things. So maybe next year we could have a hybrid mode, but not yet decided. So we'll have this executive committee meeting, and then there we will decide exactly how to proceed and how to do so. So now I request the participants to please come up and say a few words about the conference, how would you like, or what could be the things that could be accommodated here so that the conference could be made in a better way and a better shape. So every year we try our best to make it as best as possible. So there is nothing perfect. So we did a lot of mistakes, hopefully. So we need to rectify that. So I want kind of positive criticism so that we could have some space to improve upon. So please just raise your hand, maybe through online mode. Then we can, one by one, we can ask. Yeah, please. Oh, so everybody in a muted mode. So please come up, someone to start.
Hello, sir.
Yeah, hello. Nice to see you.
Yeah, yes, sir. Myself, Hemanta Kolita, as you know, you was our chief guest. Recently, we conducted one conference. So actually, yeah, I'm big influence from you. I enjoy your conference. I was 2 times in offline mode in MB Kolkata. Yeah, I really want offline mode next year. And yeah, it was fantastic, sir. In online, we are not enjoying that much actually. I feel I
Yes.
like offline only. So I'm eagerly waiting next year. If you conduct, then definitely I'll be there. And rest, so I'm learning from you. So I don't have any comment to say how to improve. I'm learning from you.
So I'm also learning from all. So learning process is never-ending process. It ends means you are at the end. So,
It's getting better and better every year. I can see that. You're doing an excellent job.
I agree.
yeah, Professor.
Hi, Carl. It's nice to see you, Carl.
Yeah.
I don't have any critiques. I think things ran really smoothly, and you dealt with whatever problems came up and got things up and moving, and you got me up and moving. So it's been great, and I appreciate your efforts and the people there that have been running things and keeping things going, and I'm excited. And the thing that I would like to see is for me to be more relaxed when I give a presentation. I tend to get rushed or hurried, and that's just a matter of experience. And I hope that I'm always nervous when I get up and speak, because I want to do a good job and get people excited about my research. So I guess being too relaxed isn't a good thing, but boy, having those butterflies in your stomach when you get started and you're wanting to get going. So over the years, I think I've been a better, or have been getting better at presenting, and I appreciate the opportunity that you give me to share my research with everyone else. Thank you.
Thank you, Carl. And it's not me alone because our full team is working with me. My scholars, my colleagues are also helping me a lot because for this online conference, I usually make it from my university. So I'm thankful to my university as well for giving me all such facilities. Because as you understand, so it's like parallel things are being going on. So a full team of my students, my colleagues are also here. So few of them are here. So may I request them also to please join me with in front of camera so that you can also have a look that at the back end who are actually managing all those things. I was just in front, but they are basically the persons who are actually helping me out all the time. So
Thank you.
Yeah. Professor Rosen, would you like to say something? Professor Rosen?
Okay. You're asking me. Yes, I didn't know when to say it because I don't want to. I don't have any critics. I'm just positive. You hear me?
Yes, we can hear you. Yeah.
Yeah. No, I'm positive. Very positive to you and your team, and also I think it cannot have been so easy to take over after your father with many things around you, but. I haven't been online all the time, but when I have been here, it has been working excellently. And it's not a coincidence, I think. I think you are very professional in handling it. And I agree with the last speaker that computers are not the most important thing to us, the other things, but they're definitely good here when we should do this type of, or have this event. Then the computer facilities or the facilities around is excellent. But I think the main that it works so well is that you are so professional. So thank you very much from my side. And those talks I've been listening to have been extremely interesting. And just hope to meet you next year. And happy Christmas, or Merry Christmas, and Happy New Year.
Okay, thank you. And we are also looking forward to see you next year. We are very much positive about to have it in a physical mode. So my students who are in Australia and in Canada, they are also working quite hard to managing all the parallel sessions and all. So Partho is there, or it's too late for Partho and too early for my another student who is in Canada now. So, but they are also helping me all the time. Okay, anybody else would you like to say a few words, please? Yeah, so Yusuf Mir, could you please unmute yourself and Yusuf, are you there? Yeah.
Good evening, sir.
Good evening.
Good evening. Good evening, sir. Sir, I want to thank you, all of you, especially to Sir Dr. Ave, sir, who being very kind personality. I've never seen that before. Because I want to share a little bit some ideas about sir. I am actually from Jammu and Kashmir. Today here is very harsh. Winters are going, so I am wearing this fan this time. It's our culture. Actually, sir, during registration process, there were all bank applications were not working. I emailed the sir about this fact that I am not able to submit the fee. It is a sir who asked me that there is no need to submit fee. You can join without fee also. So he understood my problem at that time. I was very eager to join this conference. So I have no suggestions because everything was positive here. I have joined so many conferences before also, but here I find everything positive. So I have no suggestions, but I humble request that please next year have a physical conference rather than online.
Yeah, we will try our best to make it.
Moreover, sir, I have, sir, one more request. If there is any sir from analysis field, especially from complex analysis, I want his or her email ID so that we will get more help. Thank you, sir.
So the proceedings is already there. So you can have a look at the proceedings. So if you go to the website link,
okay, sir.
The proceedings on the first day, the specialty of our conference is we publish the proceedings in the first day of the conference. So it's already there on the website. So on the right side, if you go there, you will find that the link is there available where all the previous proceedings are also available. So please have a look. With the abstract or full paper, the email ID is also there. That's the format of our conference. So,
sir, I salute your goodness. Thank you so much.
Okay, thank you very much. It's our pleasure that we get papers from every part, from north to south, from east to west, everywhere. So, yeah, thank you so much for joining us. Yeah.
Thank you.
Yes. Shopnomoy, could you please?
Hello, everyone. Respected speakers and everyone who is attending here. I am from Jadavpur University. I am thankful for this opportunity to join this webinar. There were so many beautiful presentations which would help me further in my research paper or in my education. And I really hope I can join next year and hopefully in the physical conference. That's all. Thank you.
Thank you, Swapnamoy, for your suggestions and all. We'll surely try. I mean, I'm also getting a lot of emails from others also as well to same thing. Okay, so we'll surely try for that. Anybody else? Please unmute yourself and please express yourself. Now, Umeshji, please say something. Please unmute yourself. Professor Umesh Kumar Srivastava, please. So you are muted actually.
Yes, thank you very much. I have already joined in 2018 in physical mode, and this year I am also attending in online mode, and really it is very pleasant and very instructive, and just we have I have inspired from this online mode, and I hope next year we shall meet in online mode. And rest, I pray to God to remember to our guardian, Professor M.R. Adhikari sir, to whom I met first in the Hyderabad Indian Science Congress. I pray and I worship God that the rest work of his work done, that is the book of topology and other things I want to know. And rest, when we shall meet together next year in a physical mode, we shall discuss, and I hope that all the success of your online mode conference. Thanks.
Thank you. Anybody else would like to say something? Please unmute yourself and express yourself. Yeah, Dr. Vinod Prasad, please.
Okay, thank you, sir. And I'm very grateful to INVIC, and also I'm very grateful to Dr.
Please unmute yourself. We cannot hear you.
Sir, now? Are you listening, sir?
Yeah, we can now hear you. Yeah.
Thank you, sir. And thank you, IMBIC and total IMBIC family, and especially Dr. Adhikari, sir. And I'm very grateful to all of you. And actually, I have, first of all, in 2018, I have joined your program in Calcutta physically. And I also very thankful to my guide. Actually, I'm not doctor now, I'm PhD scholar. And my guide is Dr. Umesh Kumar Srivastava, sir. And I'm very thankful to Umesh Kumar Srivastava, sir, also. He's helping me to joining such type of program, and also helping me to get the PhD scholarship, PhD courses. And that's enough. And I would like to express best wishes and grand success of this program. And actually, it will be a success. And I hope that next year I allowed or I try to join in Calcutta if you organize such a very mathematical, great mathematical successful program. Okay, thank you all of sir. And I want to express Happy New Year and Happy Krishna.
Thank you, Vinod, for your nice words. And so thank you, Vinod, for your nice words. And so you can see one of my colleagues who used to be one of my students, and from the very first conference, not first, but the second conference, he is there with me. Now he becomes my colleague, Ungshuman. So hope you can see him. You can, yes. So maybe those who are coming for longer years, they can recognize him. So yes, anybody else would like to say something? Yes. Yeah, Satya Pradhanji, would you like to say something? Okay, maybe. So now, if no one is willing to say something, just would you please? Oh, he has some mic problem. Satya Pradhanji has some mic problem. So if you can just open your camera so that we can have a group photo. Please join with us. Great. Okay, so I can see many faces and still more to go maybe. Oh, great. It's like twinkle, twinkle, little star. Okay, great. So we are missing Professor Eric Trail. So Eric and his family is actually traveling. So that's why he told that he may not be able to join us today. But at the end, what I would like to say that who is the kind of pillar for this conference is my father. At the end, we must remember him. So he is the person who actually thought of studying this conference as an interdisciplinary field. Professor Eric Trell, Professor M.R. Adhikari, and Professor Vaisikata. So three of them, they actually started working on it, and then I joined them. Professor Manikam is also one of them who is there from the very beginning, from the very beginning of this conference. And then Carl Soup and Professor Detrich, and then Professor they also motivated us to carry out this conference for a longer period of time. And I'm sure that with your love and affection, we'll continue to do so for longer period of time. Professor Day, are you there? Would you like to conclude something? Then if you are there, Professor Day, are you there? I think he's not here. So you can see another face here, Jyotirmoy, who is my student who also did a lot of work, and many faces I can see. So now I just hand it over to Professor Manikam to conclude this session.
It has been a wonderful journey for the last, I think I've been attending for the last 15 or 16 years. It has been a nice experience. Every year it is getting better and better. I see more people attending the conference, and the quality of the papers are simply great. It's very pleasing to see it. And so let's conclude this session, and then we will all meet in person next year in Calcutta. It's a wonderful time to meet in Calcutta. See you all. Take care. Happy New Year. Merry Christmas.
Merry
Bye-bye.
Christmas. Happy New Year. Bye bye all.
Merry Christmas. Happy New Year.
Happy.
Thank you.
Yes.
Happy New Year.
Merry Christmas, Happy New Year to all.
Yes.
Happy New Year, sir. My guide, sir. Happy New Year.
Well done.
Okay, then see you next year soon with the good health and all.
Yes, hoping.
We also hope that too.
Bye bye.
Next year, physically.